Good evening, everyone. Welcome to Dr. Rajkumar Academy for Civil Services. Continuing with our session of the Decode Prelims. Today, it will be geography. Geography, as you know, holds a very important place in UPSC Civil's preparation. From geography, you can expect approximately 10 to 12 questions. And today, we have with us Ilanchezhian sir, who has 12 plus years of experience. He is an extraordinary teacher. He has got a huge following in the student community too, as we know that he has been awarded the best teacher in India for civil service exams coaching, as well as he has received a 2019 award, CSR award in the field of education. Sir is very passionate of education. That is why, though he was a senior manager in a leading public sector bank, he left his job. He quit CRPF. He also had cleared CRPF, by the way, and he started teaching geography for civil service aspirants, as he is fond and very passionate about teaching. And sir has the rare distinction of clearing 17 highly competitive examinations. He's been a topper in UPSC CAPF examination, and he has appeared in 3 UPSC interviews. I think this itself speaks volumes about sir's excellence and sir's ability and capability. And today, sir is with us to discuss about geography, to discuss the questions, to help you guys understand how to look at your geography, how to use logic in solving the questions, as well as how you have to study for the next 10 days with respect to geography. So, all of you, please welcome Ilanchezhian sir.
Thank you, brother. Thank you.
Yes.
Yeah. So, very good evening, friends. See, today, what we'll be doing, majorly I'll be concentrating on those areas where the probability of the question is. Okay. So, in a way, I'll try to touch the different areas of this physical geography, right? Human geography I may not touch, but maybe say, for example, right? Say, for example, extension of the physical geography in the name of soils. Maybe say, for example, in the name of biospheric reserves, if needed, we'll be just touching upon. Okay. So otherwise, the larger area of focus will be physical geography and the question potential areas as such. Okay. And see, the last few days, right? Hardly last 10 days or there. Somewhere I feel that you cannot study something altogether. Okay. So whatever you have already studied, that alone, say, for example, we'll take it very seriously. We'll be going for a kind of a revision. Okay, you revise and practice. Okay, try not to study something altogether new. Okay, so right, my dear friends. Now, maybe as I said, I'll just start with this physical geography. Some of the topics, almost say, for example, I'll be browsing through all the topics, right? If at all, if I feel that it is not so important right at this moment, right, I'll be just skipping it. And today's class will be based on this return on investment, right? So where exactly my time of investment can be less, where the mark or the question asked will be slightly more, that will be our area of focus. Right, my dear friends. Now, whenever if you have a doubt, say for example, this part means somewhere the chat box itself, you can just post me that, right? Whatever the doubts you have, you can post me. Okay. So in a way, while browsing through the topics, I'll also let you know that we'll take some of the previous year's question for practice. And though we say that UPSC do not have any format as such, right? Generally, we say UPSC is more like unpredictable civil service commission. But there are few things which you can predict. For example, the language of UPSC is similar. The nuances, what is somewhere hidden in the questions, there will be a similarity. Okay. So in a way, geography questions or geography related questions, how few words in the questions will make you to answer the questions as such, something we'll be seeing. Okay. Right, my dear friends. Now, I'll get into the topic. See, can I just talk about this physical geography of the world? Largely, we'll be having 4 broad areas. One, some basic introduction I can include it. Apart from the 3 broad areas we can discuss. Number 1, we call them as geomorphology, study of landform features. Number 2, we call them as climatology. Number 3, we'll be talking about oceanography. Okay, these are the 3 broad areas what we'll be, say for example, somewhere we'll be looking upon. Okay, right. Now, When I just talk about this very basic introduction, right? Very basic introduction. Maybe the, just a minute, please. Okay. Now here, if at all, if I'm just browsing through some of the topics in the so-called introduction, right? All these miscellaneous topics of this physical geography, where I can take G.C. Leong's chapter 1 as my textbook. And my dear friends, uh, all these years, one thing is for sure. Some of the very popular subjects you take it, in the market, you have some standard books. But when it comes to the subjects like geography, there is no very popular standard books available in the market. This is the place where I would recommend students that you go with NCERT, right? NCERT books as a textbook. See, somewhere I believe, maybe during the course of the lecture, I'll show you, even last year, 2024 examination, 8 questions. 8 questions, almost it is picked from one single book of geography. This book, you call them as what? Fundamentals of Physical Geography, the very first book of class 11, NCERT Geography NCERT. Line by line, you will be finding that this is given in NCERT. Even last year, 2023, which is considered to be one of the toughest examination, right? Even there, I can see the few questions are directly asked from what? NCERT. That's the reason always we feel that NCERT, for geography, somewhere I feel that this should be a fundamental book what you study. Okay, right. Now, having said this, just browsing some of the topics of this introduction. Say, for example, we'll be talking about something like shape of the earth. Forget about it, not needed as of now, right? When I just talk about earth movement, right? Somewhere again, the questions are not so much asked in this topic. Okay. Now here, one area where repeatedly I find that questions are being asked is about the season cycle. Season cycle. See, on an average, once in 2 years or once in 3 years, they have one question coming from season cycle. For example, they'll be talking about the different seasons of the year. Okay. When they talk about the different seasons of the year, at least 4 very important days of the seasons are there. Of course, I know seasonal classification may vary from place to place. For example, if I am there in equatorial region, there is no concept of season. As I move away from equatorial region, seasons are very distinctive. Okay. And similarly, my dear friends, the seasonal classification of India is different. Excuse me. The global classification of season is different. Okay. So whatever it is the case, when I just talk about the global classification of the season, there are 4 seasons. You call it as summer, you call it as winter, you call them as spring, you call them as what? Autumn. So here, generally we'll be discussing about 4 very important days of a season. Okay. For example, when I just talk about June 21st, you call them as what? Summer solstice. If you're there in northern hemisphere, this will be the longest day, right? Similarly, when I just talk about, say, for example, December 22nd, we call them as what? Winter solstice, the shortest. And between this summer solstice, peak summer day and peak winter day, we have 2 other days of transitional phase. You call them as what? Equinox. One is on March 21st and another is on September 23rd. You call them as what? Spring equinox or vernal equinox. And September equinox, we call them as what? Autumn equinox. Okay, whatever it is the case, right? What is season? Why exactly we have seasons? What is the reason for season? That and all, it is okay. But say, for example, from 2019 to 2024, the span of 5 years, roughly around 5 years, my dear friends, we had 3 questions coming from this particular topic, right? And that too on the single day. Their major focus is on June 21st. Even last year, there was one question on June 21st. Okay. See, going by that logic, somewhere I feel that this year they may not ask, but still I want to tell you that this is a question potential topic, season cycle. Okay. So what is a season? The variation in the length of day and night, you call them as what? Season. Longer days, you call them as what? Summer. Shorter days, you call them as what? Now comes the question, why exactly this length difference in the length of day and night is somewhere differing, if you ask me? It is basically because of two reasons. Number one, Earth is revolving. Earth is rotating and revolving on its own axis. That is okay. But along with the tilted axis, just because Earth's axis is tilted and eventually it revolves around the sun, what happens? The two different hemisphere has a differential exposure towards the sun. At some point of time, you'll be finding that northern hemisphere will be more tilted towards the sun. Whichever hemisphere is more tilted towards the sun, exposure to the sunlight will be more, length of the day will be more. Okay. Whenever this northern hemisphere is getting tilted towards the sun, that is when we'll be experiencing summers of northern hemisphere. Right? And obviously, one hemisphere experience summer, the other hemisphere will be experiencing what? Okay. Now, my dear friend, somewhere I told you, right? What is very important here? This June 21st is very, very important. I'm just going by this completely analysis of the past year's question. Okay. 2019, one question was asked. Right? Again, say, for example, 2021, they have asked one question, if I'm not wrong. 2024 also, they have asked one question. 2021 or 22, they have asked one question, and 24, they have asked one question. Okay. Now here, this June 21st, my dear friends, it is the longest day of northern hemisphere. This is the day when sun's vertical rays will be falling over what? Tropic of Cancer. And as you move north of equator, the length of the day slowly and steadily will be increasing. Okay. The facts are very limited. The same thing can also be shared. Okay. And one more thing, all this introduction, what I'm just somewhere covering under this introduction, where can I have the reference material if you ask me? G.C. Leon, chapter 1, the first unit of G.C. Leon, right? The certificate in physics, sorry, right? Both physical and human geography. Okay. Right, my friends. Or simply you call it as G.C. Leon, the very first chapter. Rest of the topics, what I'm discussing, you will be finding in NCR. Okay. So this alone, we do not have much specified in NCR. Okay. Here and there, class 6th and 7th book we do have, but the details are not enough. Okay. Right now here, talking about the questions. Can I just talk about this 2019 question? They have asked this question. On 21st June, the sun, okay, and does not set below the horizon at Arctic Circle, does not set below the horizon at Antarctic Circle, shines vertically overhead at noon or the equator, shines vertically overhead at the Tropic of Capricorn. Okay. Now here, somewhere I'm just specifying that question is about what? June 21st. I'll come to this answer, right? Again, if I just talk about the next, say for example here, 2022. Again, what they've asked, in northern hemisphere, the longest day normally occurs in. Okay. It's more like a fill in the blanks. I have to continue. What exactly they're asking? The first half of the month of June, second half of the month of June, first half of the month of July, second half of the month of June. Means whenever they say northern hemisphere and the longest day, my answer to this question is what? June 21st. So somewhere I have to say whether June 21st lies in the first half of June or second half of June. A question cannot be simpler than this. Okay. Again, when I just talk about last year, I'll show you this last year question. Okay. So this is 2024 question. Again, what is the question they have asked? On June 21st, every year, which of the following latitudes, right? Experience a sunlight of more than 2 hours. Okay. Now here, somewhere I'm just telling you that this is a repeated question. Again, my conviction says that this year you may not have this question, but still, right? I'm just focusing on those important areas as such. Okay. Now here, what happens on June 21st? First and foremost, what I understand, This is the day when sun's vertical rays will be falling right at Tropic of Cancer, for the most limit. See, when I say sun's vertical rays, right at 12 noon, the sun's rays will be falling exactly above your head. Right? On this day, my dear friends, the length of day at Tropic of Cancer will be 13.5 hours. Night and day, if you put together, you should have 24 hours. Okay, 13.5 hours. If it is 13.5 hours of daylight, day length, the night will be somewhere around 10.5 hours. Okay. As you move north of equator, right at the equator, it is 12 hours of day, 12 hours of night. Slowly, steadily, you move north, 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 and north. What happens? Once you reach this Arctic Circle, you experience 24 hours of daylight. You experience 24 hours of daylight. It means this is the day where Arctic Circle and Arctic region will experience 0 hours of night. 0 hours of night. There is no concept of night during this particular day. It means what? Entire day sun will be there in the sky. On this day, neither the sunrise will happen nor the sunset will happen. Or I should say, sunrise has already happened. Sun is there in the sky. Sunset will not happen on this day. That is what got translated into a concept called as what? Land of midnight sun. We call it as a midnight sun. For example, countries like Norway, we call them as a land of midnight sun. So what is this concept of midnight sun? According to your watch, time will be shown as 12 o'clock. 12 p.m. Sorry, excuse me, 12 a.m. 12 a.m. is midnight. 12 p.m. is okay. Your watch will be showing midnight, say for example, 12 o'clock, right? But sun will be there in the sky. Okay. So presence of sun even during the midnight is what you call them as what? Midnight sun as a concept. Okay. So entire Arctic region, my dear friends, I'll be having sun in the sky, right? Only on this day. Okay. For example, if I'm there in the poles, sun will be there for 6 months. But as I move away from the poles, the length of continuous presence of sun in the sky slowly, steadily decreases. Right? From 6 months, it can become 5 months, 4 months, 3 months, 2 months. Outer margin of this Arctic Circle, it is 1 day. Which day? June 21st. Okay. Right. So June 21st is a very, very important day. Nothing wrong to focus on it. Okay. Now with the small idea, if I just go somewhere, search this, say for example, answer, right. 2019, they have asked this question. On 21st June, the sun does not set below the horizon at Arctic Circle. Directly, I got the answer. It means what? What they're saying. Horizon means the line along which the sunrise or sunset takes place. You go somewhere, stand in a shore, right? Very along the coastline. Okay. Once you stand the shore or a coastline at a distant region, you'll be finding the outer curvature of this earth. You'll be finding as though the sky and the earth is meeting. That line is what you call them as what? Horizon. When the sun comes out of it, you call them as what? Sunrise. When sun goes below it, you call them as what? Sunset. Okay. So first point itself, you got it. The sun does not set below the horizon at Arctic Circle. And one more thing. It's more like, what do you call this? Okay, I'll put as a disclaimer. See, somewhere I'm just discussing these topics, assuming that already you know the basics. Okay. So somewhere if I treat it like a class, I have to take the basics. Okay. Certainly speaking, all the topics, most of the topics in 4 hours, it is not possible. So somewhere I believe that already you know the basics. And based on it, I am just discussing. Okay. Right. Right, my friends. Any doubts, you can post it in the, say, for example, chat box. Now here. This is already a direct question. So no need to discuss about it. Right. In Northern Hemisphere, the longest day normally is 21st June, which is nothing but what? Second half of the month of June. Now I'll discuss about this last year question, 2024 question. What exactly they say, 24th question. Okay. On June 21st, every year, which of the following latitudes experience a sunlight of more than 12 hours? What they're asking is more than 12 hours, right? Equator, I'm just removing it because equator is only 12 hours, right? They're asking more than 12 hours. Answer to this question is very simple. Whichever place is there in the Northern Hemisphere, you take it as an answer. So my answer will be, because why I'm saying more than 12 hours? More than 12 hours means summer. Correct? Any place which experience more than 12 hours means summer. Month of June, or June 21st, which hemisphere is experiencing summer? Northern hemisphere. Okay. So whichever latitude which is given here, which belongs to northern hemisphere, will be my answer. Equator is an exceptional region. Why? Because equator neither belongs to northern hemisphere nor belongs to what? Southern hemisphere. It is a line that demarcates. To be very precise, equator is one place where I'll be having 12 hours of day and night throughout the year. Equator will experience equinox throughout the year. Okay, so if that is the case, what will be my answer? Tropic of Cancer should be part of my selection. Arctic Circle should be my part of the selection. Tropic of Capricorn I am eliminating for the simple reason Southern Hemisphere. Equator I am eliminating because it is 12 hours, not more than 12 hours. So my answer will be 2 and 4. Okay. So in between I got a doubt. Yeah, what is this doubts? Yeah. They're telling me what is the answer. Okay, good. 2 and 4 is the answer. Right, my friends. So this is one area where I feel that this is important. Okay, right. Now slowly moving on to the next topic. So all other topics, okay. Latitudes and longitudes, you can leave it. Facts about this latitude and longitude, related concepts also somewhere I'm just skipping it. Okay. Not that much needed. If at all, if it is there in news, it is needed. Otherwise, it is not needed. Okay. International dateline also I can skip it. Twilight I can skip it. Coming to geomorphology. See, geomorphology is the largest topic of geography. Geomorphology is nothing but what? Study of landforms. Okay. Now comes the biggest question. What do you mean by land? See, physical geography, I'll be studying primarily about 3 entities. I'll be studying about land, I'll be studying about air, I'll be studying about water. Okay. So in this image, everything is there, right? When I study about this land, all this land, including mountains, I call them as what? Geomorphology. If I study about water, I call them as what? Oceanography. If I study about air, I call them as what? Climatology. Right? There are 3 spheres what we study. We study about air, we study about land, we study about water. That is what is all about the physical geography study. So geomorphology is that study where I'll be somewhere studying about what? Land or landform formation. Now comes the biggest question. Everything is fine. What is a land? Very simple, my dear friends. This Earth is divided into different layers, right? Among them, if you ask me which is the outermost layer, this outermost layer, we call them as what? Lithosphere. Either you call them as lithosphere or you call them as what? Crust. Technically, there is a difference. Okay. But I have a liberty to use it interchangeably. Okay. Now comes the question, what do you mean by land? For example, geomorphology itself is a study of landforms. Then what is a land? What is a land? Okay. Now see, I have a layer called as lithosphere. Whatever lies in the outer surface of lithosphere, but located above the mean sea level. Correct? You call them as a land. Or make it very simple. Whatever lies in the outer surface of this earth, but located above mean sea level, you call them as what? Landforms. The same definition, if I just take it, whatever lies in the outer surface of lithosphere, but below mean sea level, right? We call them as what? Oceanic features. Continental shelf, continental slope, abyssal plains, mid-oceanic ridge, deep sea trenches. All this we call them as what? Oceanic features. Okay. So geomorphology is the place where I'll be studying about the outer surface of the earth above the mean sea. That is what you call them as what? Land. Now, if you ask me what are the different types of land I can have? Majorly, what are the different forms in which the land can exist? If you ask me, it can exist in the form of a plateau, mountain, or plain. Sometimes also as what? Okay. But however, mountain, plateaus, and plains happens to be the major landforms as such. Now, entire geomorphology, I'll be studying about these features. Okay. Now, my dear friends, when I just talk about these features, right? It can be plateau, it can be mountains, it can be plains. Now, here, when I just talk about, say, for example, geomorphology, as I said, geomorphology is a study of landforms. Any landform you take it, it is the result of some geomorphic process. All that set of forces which acts on the surface of Earth, which can eventually modify the same, you call them as what? Geomorphic process, right? Geomorphic. Morphic means changes. Okay. Right, my difference in that way. Any landform, if you ask me, any landform is a set of two different forces acting on. What are the two different forces? One, I call them as what? Endogenic force. And two, I call them as what? Exogenic force. All that force which acts from within the Earth's interior. Origin, genesis will be from the Earth's interior. You call them as what? Endogenic force. Acting from outside the Earth's surface, you call them as what? Exogenic force. Right? Now, my dear friends, somewhere I'll just put it in principle. Right? Right? Assume that this is the surface of the Earth. All set of process that acts from inside the Earth, you call them as what? Endogenic. And outside the Earth, you call them as what? Exogenic. Okay. And both will be acting where? On the surface. Right? Endogenic force will try to increase the height of the feature. Exogenic force will try to reduce the height of the feature. Right? Endogenic force is very, very important. Particularly for examination purpose, if you ask me, right? Endogenic versus exogenic, which is very important. If you ask me, I would say endogenic is very important. But last year, there was one question on weathering. Otherwise, barring that exception, mostly endogenic is very important. And one more thing, let me tell you. Geomorphology is the largest chapter, which will take much of your time for preparation. But let me tell you, geomorphology is not that much important for prelims. Geomorphology is largely important for mains examination. Okay, not that much for prelims. Okay, but still, if you ask, okay, for prelims, see, prelims, technically speaking, the syllabus for preliminary examination is more larger than that of what? Mains examination. For preliminary examination, I have entire geography. Mains examination, only few topics of geography. Okay, that way, let me tell you, my dear friends, try to concentrate on this endogenic force. In that endogenic force, you try to concentrate on this sudden endogenic forces, right? Even the sudden endogenic forces, I would say, more than volcanic activity, I would somewhere say earthquake is more important. Okay. In that way, what I can do here, right? Climatology is very important for us. More topics we'll be discussing in the chapter of climatology. Okay. So what I would recommend, what are the topics I can concentrate here in this endogenic process? Right. Number one, endogenic versus exogenic. If you take it, I would recommend that endogenic is very, very important. For preliminary examination, if you ask me what are the topics, I would say sudden processes comparatively important. Okay. Along with this, what else I can add it if you ask me? Maybe I can add, say, for example, right? Say, for example, the topics or theories. Some of the theories I can include. Theories of endogenic forces. I may include only two theories. Number one, we call them as what? Continental drift theory. Number two, we call them as what? Plate tectonic theory. Right? Three, if at all, if you can have a glance, right? There is something called as what? Sea floor spread. We call them as what? Sea floors. Okay. So this three theories superficially, if you can add it only from NCR, don't go beyond NCR. What exactly they say, right? If you can add it, that is more. Along with it, I would recommend, because endogenic force, the genesis origin is coming from Earth's interior, I would recommend that you also go through this internal structure of the Earth, or you simply say Earth's interior. Okay. So I repeat again, the topics, what I'm just suggesting you to somewhere have a glance. In geomorphology, Earth's interior or internal structure of the Earth, right? Then some of the very important theories on endogenic forces like continental drift theory, plate tectonic theory, and seafloor spreading. Then when it comes to sudden process, volcanic activity and earthquake, if you want to give more emphasis, I would recommend that you give more emphasis to what? Earthquake. Okay? Right. Right, my friends. And one more thing. This earthquake, and internal structure of the earth, they are correlated. Why? Because today, how did we come to the conclusion that this is how the earth's interior may look like? If you're asking me, I would say it is all because of the seismic study or seismology. That's the reason even today, earthquake, we say that earthquake act as windows to Earth's interior. How did you identify that these are the different layers in Earth's interior? It is all about studying about what? A concept of shadow zone. And shadow zone itself is associated with what? Earthquake as such. Now, of course, I'll be taking to the only topic of geomorphology called as what? Earthquake. Okay. Now here, all these topics I am just leaving it. Even geological timescale, one such question, right? One question came from the grid what we have developed. But somewhere I feel that just because of one question, right, taking everything is not okay. Right, my friends? Maybe internal structure of the earth, I'll just give you a gist of it, right? Internal structure of the earth. See, and interestingly, more questions have not been asked in internal structure of the earth. But still somewhere, because last few years, so many, say for example, almost news about this internal structure of the earth, we are just, say for example, hearing. For example, there was a news about something called as what? E prime layer. E prime layer. Very recently, they have discovered this E prime layer. And where exactly this E prime layer is located, if you ask me, somewhere around this Gutenberg's discontinuity. They also discovered something called as red, or say for example, almost redwoodite ocean, right? A ocean in Earth's interior around the 700 kilometers of depth we have identified. And this ocean, say for example, it is almost 4 to 5 times bigger than the ocean what we have in the surface, right? Sorry, we call them as what? Ringwoodite ocean. We call them as what? Ringwoodite ocean. So there are many discoveries that is coming in the recent past about this internal structure of the earth. So in a way, somewhere I feel that given the context, that internal structure of the earth is important. Okay. Now, my dear friends, whenever I just talk about the classification of the internal structure of the earth, in two ways I can classify it. One, I can classify it based on the composition. What exactly this layer is largely made up of, right? That is composition, right? On the other hand, I can also classify this layer based on the mechanical state of matter. Whether this, say for example, this layer is solid, their layer is liquid, or whatever it is the case. Okay. So if I'm just classifying them based on the mechanical state, I call them as mechanical layer. If I'm classifying the layers based on the composition, I call them as what? Compositional layer. And obviously, you know, right? What is very popular, if you ask me, this compositional classification is very popular. Accordingly, we classify them as crust, mantle. Crust, we popularly call it as Sial. Sial stands for silica and aluminium. Mantle stands for silica and magnesium. Core stands for nickel and ferrous. Okay. On the other hand, if I just classify the layers based on the mechanical state, outermost solid layer, we call them as what? Lithosphere. Below this lithosphere, I have a layer of magma, a reservoir of magma. We call them as what? Asthenosphere. Partially molten, semi-solid. Neither solid nor liquid. Okay. Then I have a layer of solid called as what? Mesosphere. And what does this see? When talk about this mesosphere, internal structure of the earth also, interiors of the earth also, we have a mesosphere. And in atmosphere also, we have one mesosphere. Any middle layer, you call them as what? Mesosphere. Wherever it is. Meso means middle. Okay. And when it comes to the core itself, we divide them into two layers. The inner core is liquid and outer core is what? Solid. That's what we call them as what? Outer liquid core and inner solid. And my dear friends, just because this inner core is solid and outer core is liquid, what happens? This, in this image, what you see is the solid core, right? The solid core itself will be going for a kind of a drip. Another thing, this core is primarily responsible for inducing the geomagnetic property of this. So two things. Because this core is drifting, because see, I have this solid core. Solid core is all sides surrounded by what? Outer liquid core as such. Okay. Now what happens, my dear friends? This core itself will be having its own movement. You call them as a drift. And once in 70 years on an average, right, there will be a reversal of this, say, for example, movement you will be encountering. And again, last year, this was there in news. People say that, okay, the so-called scientists say that the core has reversed its direction. The core is reversing in direction. What all it will be doing? It will be changing the geomagnetic property of the Earth. The north and south magnetic pole will change from place to place. Of course, they are changed. Okay. Again, it was there in news last year. Okay. So for that reason, I would again suggest that yes, even core is very, very important. Okay. Right, my dear friends. Now here, where to focus upon, right? Focusing is very simple. Wherever you have this current affairs information, right? I'll give you this current affairs information for a minute. See, when it comes to the internal structure of the Earth, as I said, number one, I was just talking about this Earth's core that has stopped and it started spinning in the opposite direction. And one more thing, when it comes to geography related current affairs, I can go up to 3 years. There's not only current events, I can also talk about what contemporary events. There are instances where questions will be taken out of the development which has happened for the past 3 years as such. It may not be asked as a current affairs based question, but if you ask me why exactly this question was asked in the examination, that will be having a relevance with what? All that events which has happened in the last 3 years. Okay. So one is reversal of the core. Number two, I was just talking about, say, for example, one ocean, gigantic ocean that was discovered below the surface. This ocean is very popularly called as what? Ringwoodite ocean, right? Ringwoodite ocean. Here it is mentioned. You call them as what? Ringwoodite ocean. Almost where I'll be having form means water in the form of crystalline forms I'll be having. Okay. Again, this was very recently, it was there in news. Okay. And say, for example, there was also one more reason, right? They have discovered a layer called as what? E prime layer. E prime layers. This is another reason why exactly the internal structure of the Earth was, right, almost being discussed. Okay. Right, my friends. I have just given you the logic behind the questions that can be asked. Right. Now, if I just talk about, say, for example, the questions per se. Okay. I would say that more than the mechanical layer, if at all, if I can concentrate on the composition layer, it is very, very okay. First crust, outermost solid, okay, or that outermost composition layer, you call them as what? Crust. Crust is largely made up of what? Silica and aluminum, right? Mantle is made up of silica and magnesium large, right? And wherever this crust and mantle goes for a kind of a demarcation, the demarcation is called as Mohor's discontinuity. The entire name you call them as what? Mohorowitz discontinuity, or in short, I call them as what? Mohor's discontinuity. Whereas, where exactly this mantle and core is demarcated, if you ask me, at the depth of 2,900 kilometers, and roughly you call this discontinuity as Gutenberg's discontinuity. Okay. Now, my dear friends, more than everything, if you ask me, okay, number one, if you want to remember the discontinuity, it is good. See, there are actually 5 discontinuities. Conard, Moho, Repeti, Gutenberg's, and Lehman, right? But if you ask me among the 5, which is major, major is only. Crust and mantle is separated by Moho or Mohorowitz. Mantle and core is separated by Gutenberg. Okay, this much you remember, this should be more. Now here, in the entire, say, for example, internal structure of the Earth, where I should have a slightly more, say, for example, idea or in-depth idea, I would say it is all about what? Crust. Why I'll tell you, see, basic information, it is fine. Crust is the outermost layer, primarily made up of silica and aluminum, so and so. And one more thing, my friends. Imagine a condition. The examiner is asking you. See, generally what happens? Normally we'll be having a perception. Whatever I read, whatever I heard is a fact. Whatever I have not heard, it is not a fact. Never say, for example, have this mindset. Why I'm telling you? Any book you read, say, for example, even including NCERT, they say crust is majorly made up of silica and aluminium. Having said this statement, and immediately the examiner is asking you, which is the most abundant element in crust? I'm giving you open-ended. I'm not giving you, okay, I'll give you options. Right, I'll give you options. What I'm asking, we know that everywhere we have studied that crust is majorly made up of silica and aluminium. The examiner is asking you, which is the most abundant element in crust? A comes in the name of silica. Okay. B comes in the name of aluminium. 3, I'm just taking, say, for example, ferrous or iron. Okay. And say, for example, D, I can go for what? Oxygen. Now you tell me, my dear friends, according to you, which is the most abundant element in crust? Very good. Appreciate it. Most of you got it right. Most of you got it right. Answer is oxygen. Nearly 47% of Earth's crust is composed of what? Oxygen. Silica constitute only what? 28%. But even then, the crust itself, we call them as what? Silica or Cl, which is silica and aluminum. So what I want to say, what we do not know doesn't mean that they do not exist in this world. Okay. And these informations or these facts sometimes becomes very, very important also. Okay. So what I want you to do, try to concentrate in this crust as a topic. Okay, fine. I have just given you one, say, for example, fact. Now here, what is very, very important for me to understand logically, there are two types of crust. One is continental crust and two is what? Oceanic crust. Now, this is very interesting. What is continental crust and oceanic crust? Name itself says. See, I have lithosphere. For time being, lithosphere and crust, let me use it interchangeably, but still there is a technical difference. Entire crust is lithosphere, but entire lithosphere is not crust. Okay. Now here, I know what is a land. Whatever lies below the land, that part of crust which is located below the land, I call them as what? Continental crust. That part of crust which is located below the ocean floor, I call them as what? Oceanic crust. Okay. Now, examiner is giving you this statement. Okay. Statement A. Okay. Continental crust is located only below the land. Okay. I'm giving you a statement. Okay. Let this be a statement. Now, simply you tell me, is this statement right or not? Is it right or not? Yes or no? The statement is right. The statement is wrong. This one should be. I've given you a statement saying that continental crust is located only below the land. Okay. Wrong. Very good. Very good. What you said is perfectly right. Answers. This statement is actually wrong. If you ask me why, it is all because of this word called as what? See, I would suggest, whenever you come across one extreme word in the sentence, particularly questions, 90% of the time, the statement would be wrong. Geography is one subject where this logic will be applicable. Not only for geography, even environment, this logic will be applicable. Even science and technology based question also, this logic will be applicable. That's the reason always we say extreme words, words like only, words like all, words like never, words like none, right? Words like shall, right? Words like no, no is also an extreme word. Whenever this words comes in your statement, my dear friends, 90% of the time, you find it in your question paper. If these words are coming, I'm telling you, right, 90% of the time your answer will be wrong or the statement will be wrong. On the other hand, when you come across words like some, when you come across words like may, right? When you come across words like, say, for example, right, I said, okay, only, some, may, okay, possibly, whenever, say, for example, right, such words are coming in there, more words I can add it. Okay. Most of the time, the statement will be what? Right. Okay. Whatever it is, right? Forget about this word only. I'll tell you why exactly the statement has become wrong. Because I understand when I just talk about features like continental slope, continental rise, these are the features which is located below the ocean, but very much part of what? Continental crust. The name itself says what? Continental slope. The name itself says what? Continental rise. It says that I am part of continental crust. Okay. So most of the time, as I say, okay. So when I talk about continental crust, whatever lies below the land is continental crust, but marginally also extends into ocean, transitional phase. But oceanic crust is completely located below the ocean. Now, the point, what is very important and interesting is that when I talk about this, generally when I talk about crust, when I talk about crust, we say crust means sial. Crust is sial. Why we call it as sial? Because I know this crust is largely made up of silica and aluminium. But interestingly, only this continental crust is sial. Whereas when I talk about this oceanic crust is sima. Then comes one more linkage. What is this linkage? How come this oceanic crust is sima? Very simple, my dear friends. Because nature of the rock itself is different. Continental crust, right? They are made out of light density granitic rock. Oceanic crust is made up of high density, heavy density basaltic rocks. Oceanic crust is heavier, continental crust is light. That is okay, right? Oceanic crust is thin, continental crust is thick. But why oceanic crust is sima? Okay. On the other hand, I have to somewhere correlate it, right? Mantle happens to be my sea. Okay. If I just go for it, I know mantle is sima, crust is sea. And let me tell you, my dear friends, when I talk about this asthenosphere as a layer, asthenosphere is what? Magma. Right? Entire magma reservoir, asthenosphere itself is located where? Mantle. Or I'll put it this way, right? This entire asthenosphere or magma is nothing but what? Sima. Okay. So whenever this magma comes to the surface of the earth and forms some rock structure here, generally we call them as what? Basaltic rocks. Or this rock, we call them as what? Basalt. So any rock which is made out of solidification of magma or a substance which has come from asthenosphere or mantle, right? We call them as what? Basaltic. Entire oceanic crust is what? Basaltic. It means the entire ocean floor is formed from the magma which has come from what? Mantle. Once you read the seafloor spreading as a theory, that you'll understand. Seafloor will be spreading. It opens up, magma comes out, solidifies. Again, it spreads out, magma comes out, solidifies. Okay. And that's the reason, my dear friends. Generally, when I just talk about this oceanic crust and continental crust, oceanic crust is completely made from the substance which has come from mantle. Right? And that's the reason. Because mantle is sima, oceanic crust is also sima. And if you ask me age-wise, which crust is older and which crust is younger, continental crust is old. Oceanic crust is young. The youngest, or I'll put this way, the oldest rock of the ocean, approximately they are as old as 300 million years old. Approximately. Rocks of Mediterranean. If you ask me, how old is this continental crust rock? They are as old as 4,600 million years. See the difference. Okay. Why? Because this oceanic crust will be going for a kind of a recycle. It will be going for what? Rock cycle. New crust will be formed. Old crust will be destroyed. Okay. It will be going for a kind of a, say, for example, cyclical process. But continental crust is not like that. Okay. Now, a difference here. Understanding the two different types of crust is very, very important. Right? What exactly this crust is largely made out of? I repeat again, continental crust made up of light density granitic rock. Oceanic crust is made up of high density basaltic. Oceanic crust is heavy. Continental crust is light. As I already said, oceanic crust is largely made up of what? Sima. Whereas continental crust is made up of what? Sima. Right? And if you ask me, this crust do not have uniform thickness. They vary from place to place. Where exactly I'll be having maximum thickness of continental crust along tall mountain chains. Wherever this continental crust goes for a convergence, I'll be having tall mountain chains. Every mountain will be having a root. For example, my difference generally we say, whatever is the structure you find it above the mean sea level, nearly is only what? 1/10, 10%. 90% I'll be finding what? Below the surface. We call it as a mountain root concept. Every mountain, what you find, it is more like a glacier that is floating. What you find, if at all, if I find a large iceberg which is floating, what I find is only 1/10 or 10% of the height which is floating above the mean sea level or above the water. Nearly 90% will be what? Below the same logic is applicable. Wherever I have a mountain, there the thickness of the crust will be very, very high. Okay. To be very precise, it is strongly believed that where I have Himalayan region, that is the place where I'll be having the thickest crust. Where minimum oceanic divergence. Right? Wherever I have this mid-oceanic ridge, there I'll be having what? Minimum. Okay. And let me tell you, whenever this oceanic crust and continental crust goes for a convergence, right? This is the place where I'll be having the formation of a trench. Very simple. Because oceanic crust is heavy, right? Oceanic crust is heavy. Oceanic crust will be going for a process called a subduction. When heavy rocks and light rocks are somewhere converging with each other, oceanic crust being heavy will go below another. Whenever one rock enters below another, the process you call them as what? Subduction. Subduction eventually leads to destruction, right? And destruction will be resulting in what? Volcanic activity. So wherever I have trench, it is the same place I'll also have what? Volcanic activity. Okay. Right, my dear friends. Now here, internal structure of the earth, somewhere I feel concentrating on crust is very important. Adding few other informations from regarding mantle and core, if you can add it, more than enough. Others are not. Okay. So slowly, I'm just say, for example, moving beyond after internal structure of the earth, when it comes to endogenic process, slow movements, as of now, not needed. I'll discuss about sudden movement. Even in the sudden movement, I'll discuss only about what? Earthquake. Okay. Somewhere concentrating on those areas as such. See here, I told you, apart from this process, there are some of the theories which is important for your examination. I'm just giving you a suggestion. Continental drift theory, NCERT is enough. What is continental drift theory? Nutshell, you read it. Evidence or arguments in support of continental drift theory, that so many points they have given. Jigsaw fit of the shape, process, structure, right? Rock similarity, fossil studies, right? Say, for example, tillage, all this, what is given in NCERT, that alone you listed, that should be more than enough. Okay. Then in NCERT, also look for this topic called as plate tectonic theory. Right? Plate tectonic theory. Largely, it will be discussing about the different types of plate boundaries in the world. Okay. So what are the different types of plate boundaries? What are the major plate boundaries we have? You concentrate. When I talk about the major plate boundary, my dear friends, though let me not discuss taking the time as consideration. Somewhere, try to concentrate around this Pacific Ring of Fire. The world's single largest continuous destructive mountain. Nearly 40,000 kilometers of linear extent it has. Right? Almost, say, for example, if I'm just going around the perimeter, right, along the periphery of the Pacific Ocean, nearly 40,000 kilometers of continuous subduction zones we have. Okay. We call them as what? Pacific Ring of Fire. Sometimes you also call them as what? Circum-Pacific zone. So kindly concentrate in this particular area, where I'll be having plenty of volcanic activities that is taking place. I'll be having, say, for example, trenches. Everywhere I'll be having a trench. And wherever I have a trench, it will be resulting in the genesis of tsunamis. This region is known for large earthquakes, etc. Okay. Try to concentrate here. So directly, I will take you to sudden endogenic force called as what? Earthquake. Now, see, what is an earthquake? See, one more thing, my dear friends. Any endogenic force you take, if you ask me why exactly I'll be having this endogenic force, because see, though we did not discuss about lithosphere, I'll put it this way, right? Outermost solid layer, you call them as what? We call it as lithosphere. Outermost solid layer. Okay. Now, when I just talk about this outermost solid layer, this layer is actually floating over a layer of asthenosphere. Asthenosphere is magma, partially molten, semi-solid. So what happens? This lithosphere is actually floating over what? Asthenosphere, right? And this asthenosphere, the magma has its own movement. That movement of magma, we call them as what? Convective magma currents. We call it as a convective magma currents. Very thin lithosphere, you take it. This very thin lithosphere is actually floating over asthenosphere. And within asthenosphere, I'll be having the movement of magma. Like a convectional cell, this magma will be. Okay. Now here, sir, what exactly happens? Given the different combinations, see, for example, what I should understand, lithosphere is a very thin layer. Entire Earth, if I just take it, the radius of this Earth stands at somewhere around 6,378 kilometers. Out of the 6,378 kilometers, lithosphere is only approximately 100 or 200 kilometers. Okay. It means what I understand, it is a very thin layer. Very, very thin layer. Right? Compared to the size of the Earth, this layer is very thin. And this thin layer is floating over asthenosphere. And the magma within asthenosphere is not stable. They're also going forward. So given all these conditions, what happens? This lithosphere is breaking into fragments and pieces. This fragmented part of lithosphere is what you call them as what? Plate. We call it as a plate. Right? Nothing but what? Fragmented lithosphere. Something, imagine that a very thin sheet of ice is somewhere floating over a lake or a water body. Suddenly there is a turbulence that is coming in the water. So what happens is this very thin sheet of ice is breaking into fragments and pieces. Okay. Something very similar to it. If at all, if I say that this layer of ice is lithosphere, that fragmented ice is plates. And once it breaks into fragments and pieces, further they'll be moving in its own direction. That movement is what we call them as what? Plate tectonic, or you call them as what? Plate movement. So what happens? If at all, if the plates are moving, there is a chance that the plates moving plates, all that you see in this map or this image, you find the different plates, major and minor plates. Okay, plenty of plates are. Given the size, plates can be divided into major, minor, and say, for example, microplates. Microplates is not named here. So what happens? These plates will be moving with respect to each other. So there is a chance here, two plates will be moving towards each other. If they're moving towards each other, if at all, if they're converging with each other, that boundary we call them as what? Convergent boundary. If it is moving away from each other, that boundary you call them as what? Divergent boundary. If it is slide passing each other, you call them as what? Transform. You call them as a transform. For example, the major boundaries are of three types. Whatever you see here, if two plates are converging, I will give you one more, maybe the better image somewhere here. If the plates are converging with each other, you call them as what? Convergent. If they're moving away from each other, you call them as what? Divergent. If they're slide passing each other, neither converging nor diverging, you call them as what? Transform. My dear friends, whenever I talk about endogenic forces, where I'll be having these endogenic forces, I'll be having these endogenic forces prevalent largely, if not only, I'm using this word called as largely where along this plate. Be it volcanic activity, be it earthquake, be it the formation of trenches or the formation of tsunami, be it the formation of fold mountains or block mountains, lava, plateau, whatever you take it, you'll be having all those happening only along this plate boundary. Or again, I'm removing this word only, largely along this plate. Okay. So volcanic activity will also be prevalent in this plate boundary. Earthquake is also confined along what plate? Why only plate boundary? Because plate boundary is the place where I'll be having, say, for example, everywhere I'll be having what? Inducement of stress. Wherever the stress is induced, that induced stress will be stored in the form of energy, right? Induced stress in the form of energy. And this energy, all of a sudden, if at all if it is getting released, that is what you call them as what? Earthquake. So, if you ask me where largely I'll be having an earthquake, my dear friends, it is largely confined to the plate boundary. Even today, for example, once you ask Google, earthquake in India, okay, earthquake in India, Google will be suggesting this word called as what today. And you'll be finding that almost on a daily basis, Himalayan region will be having what? Earthquake. Why Himalaya is so prone to earthquake? Simple. Because Himalayas is located along the plate. Why northeastern India is continuously experiencing earthquake plate boundary? Why Andaman and Nicobar Island is that much prone to earthquake? Again, the answer is what? Plate boundary. Okay. Now, my dear friends, having said this, we talk about earthquake, right? Locationally, if you ask me where all I'll be having an earthquake, generally we say wherever you have a plate boundary, there all I'll be having an earthquake. So, what is an earthquake? See, every plate boundary, as I said, what I'll be having is what? Any plate boundary you take. Whenever there is a plate movement along the plate boundary, I'll be finding there is an inducement of stress. Like, for example, I'll take it this way. Instead of rock, you take a balloon. Okay. You take a balloon. I'm buying a balloon, I'm inflating the balloon, I'm blowing the balloon. When I blow the balloon, this balloon is becoming bigger. Correct. I'm inducing some stress inside this balloon. This balloon is becoming bigger. Whenever this balloon is becoming bigger, all that stress what I have induced is actually stored inside the balloon in form of some energy. Again, I'm blowing the balloon. This balloon is becoming bigger. Again, it is storing some energy. So what happens over a period of time, this balloon is getting accumulated with energy. At one point of time, this balloon is reaching the threshold limit, maximum limit. During that time, if I blow the balloon, what will happen? This balloon will burst. When this balloon burst opens, all that energy which is accumulated inside the balloon will get released suddenly at once. Right? Now, what I want to tell you, instead of balloon, you replace the balloon with a rock. Every plate boundary, I'll be having a rock. Right? Plate movement will be inducing stress. Convergent boundary, there will be an inducement of compressional stress. Divergent boundary, it will be a tensile stress. Transform boundary, it is a shearing stress. Some kind of stress is there. So whenever the stress is induced in a rock, the stress is actually stored inside the rock in form of some energy. Okay. Again, you induce some stress, energy is stored. So over a period of time, this rock will start accumulating this energy. At one point of time, this rock will be reaching the threshold limit, maximum limit, right? We call them as a threshold limit. When further inducement of stress is done, the rock will break. Whenever the rock is breaking, all that accumulated energy will be getting released suddenly, right? And my dear friends, that sudden release of accumulated energy from the deformed rock is what very popularly you call them as what? Earthquake. It means whenever and wherever you experience earthquake, take it for granted somewhere the rock was subjected to breakage. Wherever it is breaking, geographically we call it as a faulting. Fault means breakage. Fault line means the line along which the breakage is taking place. Only if the rock is breaking, I will be having what? Okay. Now, where this rock breakage will be common, plate boundary. Okay. Now, my dear friends. Now, if you ask me, okay, fine, everything is fine. What is an earthquake? Earthquake is all about that sudden release of accumulated energy. Now, my dear friends, technically, this release of energy always takes place below the surface. The exact place where the energy is released, we call them as focus or hypocenter. Hypocenter is always located below the surface. And the place where this, say for example, at that place which is located exactly above the focus and on the surface of the earth, we call them as what? Epicenter. Epicenter will be the nearest place on earth, nearest place on the surface of the earth with respect to the focus. Epicenter is also the first place where this earthquake will be recorded in the surface. Okay. So what is focus? Focus, sometimes you also call them as hypocenter. The place where this energy is released, You call them as what? Focus or epicenter. Always located below the surface. And that place which is located exactly above the focus and on the surface of the earth, you call them as what? Epicenter. And my dear friends, any earthquake, generally speaking, if you ask me, where the damage will be more, it is along with what? Epicenters. Okay. Right, my dear friends. Now, okay. And the distance what separates this focus and epicenter, we call them as what? Depth of earthquake. Either you call them as depth of earthquake or you call them as what? Depth of focus. And very importantly, this depth of focus is inversely proportionate to intensity. So what is intensity? If I want to somewhere, right? If I'm just using this word of means somewhere, alternate word for intensity, I would say intensity is all about the damage caused by an earth. Right? Either you call them as damage or let me call this what? Impact of an earth. Okay. So what exactly this particular statement says? What exactly it says? If the depth is more, deeper the earthquake, lesser will be what? The impact on the surface. Shallow is the earthquake, damage will be what? Okay. Right, my dear friends. Now, technically, I told what is focus, what is epicenter, what is depth, and what is that relation between this depth and intensity that also I right? They are inversely proportionate to each other. Now here, what is very important? Somewhere if I'm just going for a backtrack, the sudden release of accumulated energy from a deformed rock, you call them as what? Earth. Why all of a sudden this energy is getting released, if you ask me? Because somewhere this accumulation of energy is taking place. What is resulting in this accumulation? It is all because of inducement of stress. And why exactly there is an inducement of stress? If you ask me, it is all because of what? Plate movement or plate tectonic. Okay. If this plate tectonic is eventually causing this earthquake, we call them as what? Natural earthquake. On the other hand, if human activity can induce some stress, and if that activity is getting transformed into an earthquake, that earthquakes, we call them as what? Man-made earthquakes, or we call them as what? Induced seismicity. Induced seismicity. See, very recently, and I just talk about North Korea. Every often you will be experiencing North Korea on earth. And slightly North Korea is located away from the plate boundary. So somewhere suggesting what the earthquake, what you witnessed is North Korea is actually not natural earthquake, it is man-made earthquake. Now, if you ask me, there are n number of ways that how exactly human activity is getting somewhere, say for example, almost it is creating a earthquake, right? But North Korea, most of the time, it is because of the weapon testing, right? Weapon of large destructions, weapon of mass destruction, they call this. Whenever a weapon of mass destruction like nuclear weapons and others, if it is tested, right, that particular event will be recorded as what? Earthquake. Even very recently, Pakistan, away from the plate boundary, repeatedly we had some, say for example, earthquakes, somewhere nearly 4.0 in magnitude that is recorded. Say for example, unofficially they say that, okay, it is actually not an earthquake, right? It is not a natural earthquake. The weapon testing of Pakistan, human activity has triggered what? An earthquake as such. So what I want to tell you, even human activity can trigger an earthquake. Now, my dear friends, what is the logic? What are the different ways that human activities can trigger an earthquake, if you ask me? Right? What are the different ways? Somewhere I would say, whenever there is a large-scale tampering of lithosphere, very simple. See, if human activity can induce some stress on the surface of the earth, whether you add weight to the existing load or you remove the weight from the existing lithosphere, addition, deletion. Adding, removing, both can trigger what? Earthquake. Okay. Provided it is human act. In that way, my dear friends, can you tell me? And one more thing. Every time when I say adding a weight or removing the weight, large scale. Otherwise, it is negligible. Okay. Whenever there is a large scale tampering of lithosphere, that activity can result in earthquake. In that way, can you give me some examples how human activity can trigger that earthquake? Some examples. All of a sudden, assume, say, for example, naturally there is Nothing exists. All of a sudden, you are adding more weight. All of a sudden, you are removing some weight. Not some more large scale is. One example I got it. Deep mining, good. Deforestation is not the direct one, but deforestation can always be an indirect cost. Heavy construction, very good. Very good. Dams, fantastic. Dam, very good. Very good. See, my dear friends, very good. Deep borewell, nuclear weapon, fantastic. You got most of it. You got most of it. Thank you. You got most of it. See here, though there are different ways that how exactly human activities can trigger an earthquake. So far, mining as an activity has created a large number of earthquakes. Whereas construction of dams has created the large earthquakes. Magnitude-wise, it will be very large. Okay. Apart from that, right? Plenty of examples. Over extraction of fossil fuels, shale gas extraction, heavy construction. One of our friends said heavy construction. Chinese Taipei, heavy construction has created an earthquake. Over extraction of groundwater, Lorca, 2011 earthquake, Lorca earthquake in Spain, right? Groundwater, even weapon testing, nuclear weapon testing also will be creating water. But here, I have just added this word called as etc. Why? Somewhere if the question is asked in the examination, I have to apply my mind and I have to see that, okay, whether this activity of human being can trigger an earthquake or not, that much I should get satisfied. Okay. Right, my dear friends. Now, and again, what are the regions in India which is highly prone to earthquake? Generally, we call it as zone 5 in India. Except in this run of Kutch or Kutch Peninsula, rest of it, if I just take it, Kashmir Valley, Himachal Pradesh, Eastern Uttarakhand, northern part of Bihar adjoining Nepal, northeastern states, and Andaman and Nicobar Islands, all these places, somewhere if I just take it, instead of remembering the list as 1 to 7, right? What I understand, even geothermal energy, somebody has said, okay, good, accept it. Okay, now see here, my dear friends. Except the run of Kutch, what I understand, all other region, one thing is common. What is very common? If you ask me, they are located along the active plate bone. They are located along the active plate bone. Okay. And see, to be very precise, they are located along the young fold mountains. And my dear friends, wherever I have the young fold mountains of the world, take it for granted that they are prone to earthquake. Rocky Mountains of North America, Andes Mountains of South America, Alpine Cordilleras of Caucasus Mountains between Caspian Sea and Black Sea, all the young-fold mountains of South Asia, starting from Zagros Mountains of Iran, Hindu Kush Mountains of Afghanistan, Suleiman Ranges of Pakistan, Himalayas largely in India, Arakan Yama Mountains of Myanmar, Barisian Mountains of Indonesia, all these mountains, Southern Alps of New Zealand. Wherever I have young-fold mountains in the world, even Kunlun Shan and Tian Shan of China, right? And all these mountains, my friends, they are highly prone to it. Even today, if you ask me where maximum number of earthquake is recorded, it is recorded along this young fold mountain systems of the world, right? And of course, I know this young fold mountain system also include what? Himalayas. Himalayas is highly prone to earthquake. Okay. And even today, as of now, if you ask me, right, which region in the world so far in the past human recorded history has experienced the largest earthquake, it is along this Andes mountain, Chile. 1960 Chilean earthquake. That is the largest earthquake. Again, if you ask me, Andes, Chile, I have Andes mountain. Andes mountain is an example of what? Young-fold, right? Highly susceptible to what? Fine. So far, so good. Right now, my difference here, whenever I just talk about this earthquake, comes the question, how do we measure this earthquake? Generally, measuring this earthquake, we use two scales. One, we call them as Richter scale, and two, we call them as what? Mercalli scale. Of course, what India uses is what? Richter scale. But most of the developed countries will be using what? Mercalli scale. Now, what is the basic difference between them? This is very important. Richter scale, we call them as what? Magnitude scale. The Mercalli scale, we call them as what? Intensity scale. Means magnitude scale is more like quantification of an earthquake. Whereas Mercalli scale, when they say intensity, Mercalli scale will be calculating or assessing what? The impact of an earthquake. What exactly is it? It has created. That it will be assessing. What is this impact? It will be assessing the damage caused by an earthquake. What can be the damage? Damage can either be loss of life or loss of property. Right? Whenever I assess the damage caused by an earthquake to property and life, sometimes both, that is what I'll be measuring in what? Mercalli scale. But Richter scale is a quantification scale. Somewhere I said earthquake is all about sudden release of energy. If I somewhere calculate that energy released, quantify that energy released, and any earthquake, why exactly it is called as earthquake? Quaking of earth is called as earthquake. Shaking of earth's surface is called as earthquake. Right? If I just calculate the amplitude of that shaking, then again it is all about what? Quantification. So Richter scale measures the size of an earthquake. What is a size? Size is all about the energy released at the focus and the shaking amplitude at the surface. Okay. So one is quantification and one is qualification. Right? Now, my dear friends, there is one correlation. What is a correlation? Most of the time, they are directly proportionate to each other. Higher is the Richter scale rating, higher will be the Mercalli scale rating most of the time. Not always. Not always. Sometimes, very rarely, we also come across a situation where Richter scale rating will be more, whereas Mercalli scale rating will be less. Size of the earthquake will be more, but impact of the earthquake will be less. Can you tell me some of the occasions where I am talking about a situation, Richter scale rating, energy released by an earthquake will be more, but loss of life or loss of property will be less? Can you give me some of the examples? Where magnitude will be more, intensity is less. Or at least occasion, different occasion. Okay, this is one occasion where even if I have very large earthquake, the result will be less, or the say, for example, the damage cost will be less. Okay, I'll tell you, considering the time, maybe I'll tell you, okay, good. Some of you got the answers. No human settlement, very good. See, for example, normally we say, if earthquake is happening in a deserted region, loss will be less. Maybe sometimes no loss. If earthquake is happening in a populated region, casualties can be. See, earthquake as such doesn't kill people. It is a geomorphic agent. What nature has given the task to earthquake is just to modify the land. Okay. In between comes the human structure. It doesn't even affect the humans. Right? Sometimes the building may not, say, for example, withstand the earthquake. Building may, say, for example, deteriorate. It can collapse, somewhere causing the casualties. Okay, whatever it is the case. No human settlement. Very good. No human settlement is one. Very good. Any other point you can add it? Number two, what is very, very important, my dear friends? Depth of force. Depth of force. I told you, right? Deeper earthquakes will have very limited impact. In that way, the deepest earthquake, what we have recorded so far, we have recorded at the depth of 700 kilometers below the surface. That will not have any impact. If I have a very shallow earthquake, that will have more impact. So depth of earthquake matters. Okay. So depth of earthquake matters. Human settlement matters. Very good. Very good. Good points you have taken. Deep bedrocks. Deep rocks, the effect will be less. Deserts, the effect will be less. Third point, what is very important, is mitigation practice. Disaster management. Some of the countries, they are well equipped. For example, generally, when I talk about India versus Japan, if I'm just taking it, both are prone to earthquakes. Japan is prone to earthquake. India, Himalayan regions are prone to earthquake, right? Preparedness, we call it as a preparedness, right? Mitigation practice. Generally, I know similar earthquakes striking India and Japan. Generally, we feel that Japan, the casualties or the impact will be less. India will be more, because I understand Japan is well prepared to face the earthquake. disaster mitigation practice is the best practices. Right. Whereas when I talk about, say, for example, India, we are there in the learning curve, we are there in the improving curve as such. Okay. So somewhere I understand preparedness also. Okay. It means, say, for example, construction of building according to the BAS standards, which can withstand the earthquakes as such, so and so. Okay. Right. So what I want to tell you, generally speaking, Richter scale and Mercalli scale, they are directly proportionate to each other, but that need not necessarily, it should be that all high magnitude earthquake should result in what? More intensity. There are exceptions also. Right. Now, what is very important here? When I talk about Richter scale, generally we say it is a logarithmic scale. Logarithmic scale, most of the text says it starts from 1.0 as a scale rating and goes till 10.0. But what I want to tell you, this is an open-ended scale. Technically speaking, there is no upper limit. But still, why most of the book says 10.0? Because so far we have not recorded an earthquake in double digit. The largest earthquake, what we have recorded is 9.6 in 1960 earthquakes of Chile. That is the largest earthquake, what we have recorded so far. Okay. Whereas Mercalli scale is a 12-point scale. Already you will be having, say, for example, Roman letter 1 to 12. Say, for example, given in the scale rating. Every number that increases, the intensity will be increasing. One is instrumental, two is weak. What is not needed? But as the number increases, what happens? Say, for example, the intensity will be increasing. See, 12, just I have to read it. 12. 12 means cataclysmic. Cataclysmic means catastrophic in nature. Catastrophe. Total destruction. Everything is destroyed. Line of sight and level distorted. Objects thrown into the air. And what they say, the ground will move in waves and ripples. You see some Hollywood movies, right? Somewhere after a very strong bomb blast, you'll be finding like a sea wave, like a sine wave curve, the ground will be moved. That will be the impact of another. Rocks will be moved position. Landscape will be altered. And sometimes they say, even the route of the rivers will be changed. The river will be flowing in some direction. One earthquake can change the complete direction of this river. That is the, say, for example, that is what they call it as what? Roman letter 12. So, when I talk about the Mercalli scale, my dear friends, Mercalli scale rating has a scale rating starting from Roman letter 1 and to Roman letter 12. As the number increases, intensity increases. Okay. And finally, I also told you what is this Richter scale. Richter scale is a logarithmic scale. Now, small idea about this log scale. See here, though I say this scale starts from 1.0 and goes till 10.0, right? Open-ended. Every number that increases 1.0, 2.0, 3.0, if it is increases, what is very interesting, it is not arithmetic scale. It is logarithmic scale. It means, see, just for an understanding purpose, what I'm just taking 3 different earthquakes. One earthquake which has recorded 2.0 in magnitude, another earthquake which has recorded 3.0 in magnitude, another in what? 4.0 in magnitude. On the face of it, it appears that 4.0 is twice as great as 2.0. But very interestingly, Richter scale, every number that increases, my dear friends, right? Every number that increases, scale rating, or the, say, for example, magnitude increases at least 10 times. It means what? 3.0, the shaking amplitude will be 10 times more than what? 2.0. Energy released will be 31.6 times more than what? 2.0. So what I want to tell you, 3.0 is 10 times larger than what? 2.0. And 4.0 is 10 times larger than 3.0. It means when I compare 4.0 and 2.0, it is not twice larger. It is 100 times larger. That is what with arithmetics. So every number that increases in Richter scale, the shaking amplitude increases 10 times. Energy released increases by 31.6 times. That's the reason we say every number that increases, the size of an earthquake increases at least 10 times. Okay. Now, 4.0 itself is a large earthquake. 5.0 can induce greater damage. 6.0 is, right, say, for example, somewhere we say is very hazardous. 7.0 is disastrous. 7.0 is disastrous. If 7.0 is disastrous, my dear friends, Talk about Bhuj earthquake. Bhuj earthquake is only 6.9. Bhuj earthquake 6.9 resulted in the casualty of 20,000 people. Okay, I'll take it as 7.0. 6.9, I'll take it as 7.0. 7.0 has resulted in the life loss of what? 20,000 people. If that is the case, 8.0, mathematically, treating it as mathematically, may result in the casualty of 2 lakh people. Right? If that is the case, 9.0 of an earthquake, right, can result in the casualty of 20 lakh people, 2 million. 2 million. Just imagine 2 million people, right? Somewhere. See, this is crude mathematical calculation, but somewhere I'm telling you, every number that increases, the size of an earthquake increases at least what? 10 times. Okay. Now, right, my dear friends, everything is fine. Now, here. Coming to the seismic waves. This is a bit interesting and important also. During any earthquake, what happens? Different waves will be produced. Different waves. Okay, for example, when talk about, say, for example, this any earthquake, from the focus, there will be a generation of body waves. A pair of waves will be produced from the focus. You call them as body wave. And this body wave, as the name suggests, it will be traveling via the different layers of the Earth's interior. It will be traveling via the body of this Earth's interior. And this body wave will first strike this epicenter. Once it strikes the epicenter, from there, another set of waves will be produced, and they will be traveling only through the surface of this Earth. And these waves, we call them as what? Surface waves. Okay. Now, my dear friends, any earthquake you take it will be having 2 set of waves that is produced. From the focus is body wave, and from the epicenter is what? Surface waves. Okay. Now, when I just talk about, say, for example, this body waves, there are 2 waves. One I call them as what? P wave, and 2 I call them as what? S wave. And when I talk about surface waves, one I call them as what? Rayleigh wave, and 2 I call them as what? Low wave. Now, here, what will be resulting in changing the existing landform features? It will be, excuse me. Okay, what will be resulting in the changes of the existing surface, existing landforms in the surface, if you ask me, it is a surface waves. Okay, now here, on the other hand, what is the role of this body wave? Why exactly we study body wave? Very simple. We study body wave just to understand what? The internal structure of it. Okay, that's what we say. What has given the near complete idea about the Earth's interior is this body wave analysis, earthquake study, seismology acting as the windows to Earth's interior. Okay, whereas surface waves will be acting as a geomorphic agent, will be altering the landscapes, will be resulting in horizontal and vertical ground shifts as such. Now, my dear friends, understanding this body wave is very, very important. As I already told you, there are 2 waves. From the focus, 2 waves are produced. One you call them as P wave. P wave means primary wave. And 2 is secondary wave. Either you call them as S wave or you call them as what? Secondary wave. Why it is called as primary wave? Because among all the waves, the fastest moving wave is what? This primary wave. How fast? It travels at the velocity of 7 kilometers per second. You convert into kilometers per hour, it nearly travels somewhere around 25,000 kilometers per hour. Right? 25,000 kilometers it travels per hour. That is the velocity at which it travels. 7 kilometers per second. Hours, if you convert, nearly, even 25,200 and all you leave it, it is nearly travels at 25,000 kilometers per hour. See, some of the NCERT books say 6 kilometers per hour, but I have taken it as what? 7 kilometers. And these waves will not travel in the same velocity in different layers because they are body waves. The wave will be traveling in each and every layer. It will be traveling in lithosphere, it will be traveling in asthenosphere, mesosphere, core, everything. Okay. Different layers, different velocity. Average is somewhere around 7 kilometers per hour. Whereas secondary wave will be traveling at the velocity of 3.5 kilometers per hour. So it is very obvious Which wave will be recorded first on the surface of the earth? If you ask me, it is primary wave. And it will be followed by what? S. So between P and S, there will be a gap. Okay. So what comes first through the surface is what? P wave. Just because P wave is fastest moving wave followed by S. Now here, the wave propagation is very important. P wave, we call them as what? Compressional wave. Very technically speaking, we call them as what? Longitudinal wave. So why it is called as a longitudinal? It moves in alternate sequence of compression and expansion, compression and expansion. If I have a rock, if a P wave is traveling, P wave will be compressing a rock, then it will be expanding a rock. Then again, the adjoining rock will be compressed, adjoining rock will be expanded. So alternate sequence of compression, expansion or dilation, again compression, expansion and so on. That's why you call them as what? Either you call them as compressional wave or you call them as what? Longitudinal wave. Something very similar to a sound wave. How the sound wave will be traveling. Okay. Whereas secondary wave will be traveling in a, say for example, almost it will be traveling more like a sine wave, right? It will be causing a shear kind of a wave. Okay. Now what is very important here? Technically, you call them as a distortional wave, or technically you also call them as what? Transverse wave. You call it as a transverse wave. Transverse. Now, what is this transverse wave, my friends? So, very technically. When a wave is moving, whenever I just talk about the oscillation of the particle, when the particle oscillation and the wave movement, if it is parallel to each other, you call them as what? Compressional waves. Or you call them as what? Longitudinal waves. Like maybe. When they are perpendicular to each other, you call them as what? Transverse waves. Okay. Now that you can see. When I just talk about the oscillation of the particles versus the direction, if they are parallel to each other, you call them as a longitudinal wave or a compressional wave. If they are perpendicular to each other, you call them as a transverse wave or distortional wave. Okay. Now, why I'm insisting it? See, this much, somewhere you can feel that, okay, will UPSC ask this much detail? Even I had doubt. Before 2 years, even I had a doubt. Of course, this is part of my every class. Will UPSC ask, okay, this much technical? They have asked. Right? Last to last year, they have asked. Okay. I'll show you the question. This is 2023 question. Consider the following statement. In a seismograph is a device which records earthquake. P wave is recorded earlier than S wave. The statement is very much true. Why? Because among all the waves, the fastest moving wave is P wave. Okay. So how exactly it goes? Any seismogram, if you take it, the first waves that will be recorded is what? P wave. After P wave, a gap will be there. Only then what you will be recording is what? S wave. Because the velocity at which this wave travels is different. Okay. Statement 1 is perfect. Okay. I'll go for the statement 1. Statement 1 is perfect. Okay. Now you read the statement 2, my dear friends. Right? You yourself try to read the statement 2 and tell me whether this answer, the statement is right or wrong. What they say, in P wave, the individual particulates vibrate to and fro in the direction of the wave propagation, whereas in S wave, the particle vibrates up and down at right angle to the direction of propagation. I have not used to and fro. I have not used up and down. Instead, I have used this word called as horizontal and vertical, parallel and perpendicular. Okay. Either, whichever way you take. Okay. Now you have to tell me the validity of the statement 2. Is the statement 2 right or wrong? Very good. Right, it is right. Answer to this question is what? C. Both given option, both 1 and 2 is what? Correct. 2 and 4. Right. Coming one more. Once again, if I'm just coming to this fact here, I can see, right? 2 and 4. What they say in P wave, the particles are moving to and fro, right? Whereas when I talk about secondary wave, the particle is moving what? Up and down. As simple as this. Okay. All right, my dear friends. Now, yes. Now, when I just talk about P wave, S wave, P wave is more like, say, for example, sound wave. S wave is more like a, say, for example, somewhere I can say it is more like a light wave. Okay, whatever it is. Now, here, one small thing, we'll just say, for example, take it that there we'll conclude this earthquake as a topic. How are we determining the internal structure of the earth with help of this analysis? This P wave and S wave analysis. You might even see P wave is a compressional wave. P wave can compress a rock strata. Whenever P wave is compressional, P wave can change the shape and P wave can change the volume of the substance through which it is passing. It can change both shape and volume of the medium through which it is propagating by. Okay. Whereas when I talk about S wave is only distortional wave. Whenever S wave is traveling, the rocks will be thrown up, rocks will be thrown down. Am I right? So it will be changing the shape, but not volume. This fact is very important. Right? I repeat again, P wave can change both shape and volume of the medium. But S wave can change only what? Shape of the medium. Very, very important. Okay. Now here, if I just talk about the internal structure of the Earth's interior, I have only two sets of layers. Either a layer will be solid or a layer will be liquid. One exception is asthenosphere. Asthenosphere is neither liquid nor solid. But for all practical purpose, I will consider asthenosphere to be solid. Never, ever treat asthenosphere as liquid. Never, never. Why? Because if I treat asthenosphere as liquid, then S wave will not propagate by it. S wave is very much propagating. So it is not liquid. For binary classification, I can take it asthenosphere as solid. So I have only two layers. Either a layer will be solid or a layer will be liquid. Now I know that P wave can change the shape and volume both. Even if one property of the medium can be changed, the P wave can very easily pass through the solid. Shape can also be changed, the volume can also be changed. If that is the case, P wave can very easily pass by a what? Solid medium. Liquid, shape cannot be changed, but the volume can be changed. Right? If at all, if I'm just compressing, if that is the case, P wave can also propagate via what? Liquid medium. So this is very important, right? So what I understand, P wave can propagate via both solid and liquid medium, both. Very, 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 very important. Very, very important. When I talk about S wave, my dear friends, S wave can only change what shape? S wave can do nothing with what volume. Can the shape of solid be changed? The answer is yes. S wave can propagate via what? Solid. That is okay. What about liquid? S wave cannot change the shape of the liquid. It means S wave cannot propagate via liquid medium. This is very, very important. My dear friends, I said P wave can propagate via both solid and liquid medium, whereas S wave can propagate only via what? Solid medium. It dissipates in liquid medium. Right? This is very, very important. P wave will travel both solid and liquid. I don't have a layer of gas in Earth's interior. If at all, if I would have had gaseous layer, P wave would have also traveled via what? Gaseous layer. But S wave travels only via solid medium. That's the reason, my dear friends. Whenever during an earthquake, the only layer what happens to be completely liquid is outer. Everywhere I'll be finding this S wave. Everywhere I'll be finding this S wave, right? The last S wave will be recorded somewhere around 103 degrees with respect to focus. This is not North Pole. Okay, this is focus. Okay, focus. Focus can be at any place on the surface or below the surface to be precise. Right? Beyond this 103 degree, I may not have S wave recorded elsewhere. Why? Because as and when S wave enters this liquid core, it will dissipate. Right? It means nearly other side of the earth will not record what? This S wave. So wherever this S wave is not recorded, we call them as what? S wave shadows. So what I understand, the presence of S wave shadows strongly suggest the presence of liquid layer in Earth's interior. And the person who has identified the depth in which the liquid layer is present, the gentleman is called as Gutenberg. And that is why the outer boundary of this core is marked as Gutenberg's discontinuity. Okay. Now, my dear friends, we have something called a shadow zone. Wherever an earthquake body wave is not recorded during an earthquake, that region, you call them as what? Shadows. Shadow zone played a very important role in analyzing the depth of each and every. Very interestingly, S wave shadow zone I have. Very interestingly, I do have P wave shadows. Now you may wonder, what is this P wave shadow zone? P wave travels both via liquid and solid. Then how come P wave is having a shadow zone? Very simple. All about refraction. Whenever this P wave is entering from one solid medium to a liquid medium, a refraction will take place. Deflection in the path, say for example, wave propagation. Again, when it leaves the liquid medium and again enters a solid medium, again refraction will take place. Multiple refraction has also created what? P wave shadows. Presence of S wave shadow zone strongly suggests the presence of outer liquid. Whereas presence of P wave shadow zone strongly suggests the presence of different layers in Earth's interior with a different density and different state of matter. And my dear friends, both this image, if I can take it and superimpose it, what I understand, between 103 degree to 142 degree, this number may slightly vary. Some of the books has written till 105. Some of the books has written till 100. Nothing wrong. Geography itself is a subject of approximation. Why this value changes? Because the depth of focus will change. Okay, right. Now, my dear friends, between this so-called 103 and 142 on either side, none of the waves will be recorded. Neither the P wave nor the S wave will be recorded. Whereas, between this 142 and 142, S wave will not be recorded, but P wave will be recorded. Wherever any body wave is not recorded, we call it as a shadow zone. Okay. Now, my dear friends, shadow zone played a very important role in analyzing the Earth's interior. Okay. Right. It's all about earthquake. Somewhere I feel even surface wave is not needed. Surface wave travels only in the surface, slightly less in velocity than what S wave. So how exactly the velocity goes? P wave is very fast, followed by S wave, followed by surface waves. And that's my difference. One question, 2023 questions. Okay. Yeah, we have done it. So no need to see it again. I think this is what somewhere I feel it is. Some of the topics which may be important for geomorphology. Okay. Now we'll just venture into climatology. So I'll do it is 5:45. Exactly 15 minutes break we'll take it. And 6 o'clock I'll start with climatology. Right. So with your approval, I'm just taking a break. 15 minutes of break. Welcome. Yeah. Welcome back. Now see, coming to this climatology. And one more thing, my dear friend, see, last year, I told you, right, somewhere, nearly 8 questions they have asked from one single topic, sorry, one single book. Fundamentals of Physical Geography as such. Now here, line by line, they have taken from NCERT. Even I can show you the source also, right? From the NCERT itself, I can show you that where exactly they have taken. Okay. I'm not taking much of your time. I'll show you that the significance of NCERT. As it is primary source, last year's question paper 2024. When I just talk about, say, for example, one question, if I'm just taking it, right, let me go with this question number 3. Consider the following, right? Pyroclastic debris, ash and dust, nitrogen compounds, sulfur compounds. How many of the above are products of volcanic eruption? Last year, the question was about from volcanic eruption. Okay, now here, okay, all 4 is the answer. That is beautiful. But what is my purpose? I'll tell you. Why I want to show you this. Okay, this is NCRT. Okay, I'm just taking NCRT class 11, right, book. I'm just reading it. They're talking about something called as internal structure of the earth, and there they're talking about volcanic activity, right? What exactly they say? Somewhere they are defining this asthenosphere, right? I'm just reading it, right? The layer below the, okay, the layer below the solid crust is mantle. It has a higher density than the crust. Okay, that and all it is okay. The mantle contains a weaker zone called as asthenosphere. Okay, everything is fine. The material in the upper mantle portion is called as magma. That is also okay. I'm just reading it further, right? It says once it's, okay, they say once it starts moving towards the crust or it reaches the surface, it is referred as lava. The material that reaches the ground includes lava flow, pyroclastic debris, volcanic bomb, ash and dust, gases such as nitrogen compounds, sulfur compounds, and minor amounts of chlorine, hydrogen, and argon. Now see, I just underlined 4 facts, right? Pyroclastic debris, ash and dust, nitrogen compounds, sulfur compounds. And if I read the question paper, again, the same thing is given. Pyroclastic debris, ash and dust, nitrogen compounds, sulfur compounds. Line by line they have taken. And not only that, I'll show you one more question, particularly climatology. For example, right, when the first question, even the amount atmosphere is heated more by incoming solar radiation, we just discussed about it. The thickness of troposphere, okay, I'm just taking the very next question, okay, just reading it something like this. Okay, question number 4, if I'm just taking it, it says, which of the following is our correct inference from the isothermal map of month of January? They say isotherm deviates to the north over the ocean and to the south over the continent. I'll show you the same words in NCRT. Chapter number 9 of NCRT. I'm just somewhere keeping it here. Okay, just for comparative purpose. Okay, right? So what exactly they say? I'm just reading it line by line. This is your question paper, right? The isotherm deviates to the north over the ocean and to the south over the continent. And see, they, for example, they say the deviation of this general term, everything is fine. Right? I'm just coming here. They say in January, the isotherm deviate to the north over the ocean and to the south over the continent. Line by line, they have taken from NCRT. Okay. And the second statement, what they are saying, the presence of cold ocean current, Gulf Stream and North Atlantic drift makes North Atlantic Ocean colder and isotherm bend towards the north. Here you can find the same thing, right? The presence of warm ocean currents, Gulf Stream and North Atlantic drift makes the Northern Atlantic Ocean warmer and so on. Only thing what they have changed, right? Where it is, say, for example, warm ocean current, they have replaced this with what? Cold ocean currents. Okay. See here, many questions you take it, 8 questions we have identified where they have, say, for example, almost discussed, right? Line by line taken from NCRT. Okay. And one more thing, my dear friends, NCRT, that's the reason I say very important document. Even I'll show you one more question. Water vapor is a gas. This also directly you find it in NCRT, question number 12. Question number 3 also directly, 13 also you directly you find it from NCRT. I'll show you. Right. With that, I'll just get you to the topic as such. Okay. See, we have a topic called, say, for example, there is a topic, this topic is climatic classification given in NCRT. Okay. So here, they asked about a particular type of a climate. Okay. They have given, say, for example, this, the general nature and character of this climate, they have given it. What exactly is the general nature and character of this climate? What they have given, you have to identify the type of climate. Annual and daily range of temperature is low. Okay. You read this, what exactly they say? The annual and daily ranges of temperature is small. Instead of low, they are giving a small. That's all. Precipitation occurs throughout the year. precipitation occurs throughout the year. See, precipitation varies between 50 centimeters to 250 centimeters. Precipitation varies greatly from 50 centimeters to 250 centimeters. Line by line. 3 very important facts given in NCERT asked as a question. Okay. And which type of, say, for example, this climate, which type of climate will be having this, say, for example, this type of character, if you ask me, you call them as what? Marine west coast climate. Okay. Marine west coast climate. Again, line by line in NCERT. That's the reason I would say, 2 things you do it right at this moment. 2 things you do it. Revise NCERT again. There also, I'll just give you some chapters. Right, last minute, where exactly the maximum number of questions will be coming, I'll give you the chapters. That alone you revise it. See, starting your preparation today and certainly speaking, all of a sudden you cannot qualify this examination. But whatever it is the case, the best of the scenario will just revise, practice, and always try to practice PYQs. Then you go back to your, say, for example, other practice questions. And my dear friends, let me tell you, last few years, this assertion and reasoning type of question is getting repeated. Right? Assertion and reasoning. See, assertion and reasoning is not a new format of question. I would say it is more like a old wine in the new bottle. Okay. Say, for example, somewhere a decade before, assertion and reasoning type of a question is very, very popular. Though never they have mentioned this type of question is assertion and reasoning. But see here, the statement 1 is nothing but what? An assertion. And statement 2 is a reason for the assertion. Assertion is more like a fact. Right? Somewhere, reason is a causative fact. I would say assertion is more like an effect. And reason is more like a cause. Okay. Now here, see, this is also a 2-statement question. This is a 2-statement question. See, there are 2 types of 2-statement question UPSC is asking. One is assertion and reasoning type of a question where I have 2 statements. Number 2, I'll be having a simple 2-statement question. For example, question number 4, what I have discussed, it is a simple 2-statement question. Statement 1 is given, statement 2 is given. What are the 4 options given? Right? Somewhere there can be a chance that only one statement 1 is right. There is an option that only statement 2 is correct. There is an option that both are correct. There is an option that none of them is correct. But here, slightly there is a difference. Right? This is also a 2-statement question where I have, say, for example, 4 different options like 1 only, 2 only, both 1 and 2, neither 1 nor 2. Okay. But assertion and reasoning is quite different. How? In what way? See, for example, assertion and reason. First, how exactly we have to check it? Individually, I should check the validity of assertion and reasoning first. Is this assertion correct? Yes. Is the reason is correct separately? Yes. Then I have to see whether this reason is the correct explanation for the assertion. Instead, what exactly they are saying, both the statement 1 is also correct, 2 is also correct, right? And statement 2 explains statement 1. Statement 2 is reason. Statement 1 is assertion, right? If the reason is the correct explanation for the assertion, then my answer is what? A. Statement 1 is also individually correct. Statement 2 is also individually correct. And if at all, if statement 2 explains statement 1, how do I check it? Very simple. Statement 2, you write it, and you include this word called as because. Right? If statement 1 is happening because of statement 2, if assertion is happening because of this reason, if somewhere this word because is somewhere, right? When I just talk about the conjunction called as because is somewhere making the meaning, then my answer is what? A. If it is not making a meaning, then my answer is what? Okay. Then, if statement 1 is correct and if statement 2 is wrong, okay, then my option will be C. If my statement 1 is wrong and my statement 2 is correct, my option will be D. Now, my dear friends, this is one area. For example, if I'm just comparing this question number 4 versus this question, both are 2 statements. But what is the difference? Here, I have an option called as neither 1 nor 2. Okay. Here, there is no option called as neither 1 nor 2. 1 and 2, it is both. C is 1 only. D is 2 only. Okay. I do not have any option called as what? Neither one nor. Why I am insisting this is very, very simple. Because somewhere if I am able to identify one mistake in the statement, if I am reading the statement, if my conviction says that, okay, statement 1 is wrong, directly I know that D is the answer. While reading it, okay, if I know for sure that statement 1 is wrong, not even it is necessary to read what? Statement 2, because automatically statement 2 will be correct. Because I told you there is no option called as what? Both being what? Somewhere use this logic and assertion and reason. In a way, it is important. Most of the things I'm saying in my difference, most of the time, either the statement 1 will be wrong or the statement 2 will be wrong. Most of the time. Most of the time, your answer will either be C or you'll be D. In case if statement 1 and 2 both happens to be right, most of the time answer is C. Somewhere you try to solve with this in mind. Okay. Somewhere just see where exactly the mistake is all about. Maybe I'll give you a question from the last year. We'll see. Again, the answer to this question is A. Okay, the statement, maybe once we read the statement, okay, once we get into the chapters, you will be in a position to answer that question. Right, maybe we'll come back. Okay, right, my difference with this very small piece of information and the importance of NCERT, I'm getting back to the topics as such. Climatology, I told you, very, very important, right? Now see, when I just talk about climatology, it is all about study of atmosphere. Okay, right. Now, whenever I say climate, I know that climate is all about study of atmosphere, a layer of air that surrounds the earth as such. Entire chapter of climatology will be somewhere studying only about two very important aspects of this air mass. For example, when I just talk about climatology, if I want to define a climate, right, somewhere if I'm just defining, I'm not defining it. Somewhere I'm just describing the character. How exactly tropical desert, what type of climate tropical deserts will be housing, if you ask me? Tropical deserts will be having hot and dry type of climate. Again, somebody is asking you what type of climate that equatorial region will be having. It will be experiencing hot and humid type of a climate. What about polar region? Polar region will be experiencing cold and dry type of a climate. Now see, whenever I talk about a climate, even India, if I just talk about Indian climate, largely if somebody is asking what type of climate India houses, India experience tropical monsoonal type of a climate. Okay. Every time when I describe a climate, directly or indirectly, we are talking about temperature, whether it is hot or cold. Even tropical means hot. And what is the moisture? Whether it is dry or humid. Correct. When I say monsoon, monsoon is the wind which brings what? Moisture to India. Okay. So whenever I talk about climate, my difference, directly or indirectly, I'll be talking about how a temperature of a particular place is affected and how the moisture level of a particular place is affected. Okay. Now here, in that way, I know that, say, for example, climate is all about the study of atmosphere. Sometimes I call it as climate, sometimes I call it as weather. It is a basic difference everybody knows. Whenever I say reality, I should not say climate outside is good. Technically speaking, weather outside is good. Okay. Day-to-day changes that takes place in atmosphere is weather. Weather is so erratic, so dynamic, you cannot study it. So normally we collect the average weather values. At least we collect the average weather value for at least 30 years. And the consolidated fact, we call them as what? Aggregate weather, you call them as what? Climate. Okay. So for example, I'm just talking about climate. Now, this is very important. When I say climate is a resultant aspect of atmosphere. Studying about the temperature and moisture aspect of this air mass, you call them as what? Now comes the question, what determines this climate? What brings the moisture to a particular place? Horizontal movement of air mass, we call them as wind. Even monsoon is a wind. Why there is a wind, if you ask me? Because it is all because of what? Pressure difference. Wind always moves from high pressure to low pressure. Why there is a wind? It is because of pressure system. Effect is wind, causes what? Pressure. Wind always, as I said, moves from what? High pressure to low pressure. Then comes another question. Why exactly I have pressure difference? It is all because of what? Temperature difference. Wherever I have high temperature, I'll be having what? Excuse me, low pressure. And wherever I have low temperature, I'll be having what? High pressure. Most of the time, they are inversely proportionate to each other. Okay. And what exactly is predominantly determining the temperature of this atmosphere is what? Insolation. Okay. Insolation and temperature, they are directly proportionate to each other. Now, my dear friends, I'm just giving you a forward linkages, right? The energy that comes from the sun, the trace amount of heat that Earth as a system receives from the sun, you call them as what? Insolation. Though insolation, almost the variation of insolation is between the different days of the year is very, very minimal. Whatever it is the case, the amount is almost static. Barring the exception of perihelion and aphelion, insolation received from by the Earth as a system is more or less static. But what differs is distribution. Few places insolation will be concentrated, few places it will be distributed. Okay. Depending upon the distribution of insolation, temperature is also affected. And they are directly proportional. They're directly proportional. Wherever, say, for example, I have more concentration of insolation, temperature will. Wherever I have the distribution, temperature will. Depending upon the temperature, pressure is two types of pressure. I'll be talking about low pressure, I'll be talking about high pressure. Intensified low pressure, I call them as cyclone. Intensified high pressure, we call them as what? Anticyclone. Pressure system will create or will be resulting in the horizontal movement of air mass called as wind. The wind is a compensatory mechanism. Wind will be flowing till the time when there is a difference between high pressure and low pressure is null. While wind is moving from one place to another, wind will be carrying the moisture, collecting the moisture, carrying the moisture, and deliver the moisture, and the resultant climate will be created. So wind not only carries the moisture, it also carries that temperature, say for example, anomaly or temperature also, right? The heat also it carries. That should be right. Okay. Now, my dear friends, entire climatology, actually speaking, we'll be discussing about the different aspects of the same that is being displayed. Okay. We'll be discussing about insolation, distribution of insolation, temperature and distribution, different types of pressure systems, right? Wind, and the two predominant places where I'll be having a wind, and classifying the wind based on the size like planetary, regional, local winds, and flowing at tropopause level, you call them as what? Jet streams or upper air waves. Okay. And finally, we'll be discussing about climate, right? At least, see, just we'll be traveling and I'll be telling you that what exactly is important. That should be, I mean, given the time constraint, only that we can. Okay, now coming here. Climatology is a study of atmosphere. Okay, it is a study of atmosphere. In that way, generally we say, when I talk about, say, for example, atmosphere, my dear friends, what is atmosphere? The layer of air that surrounds the earth, you call them as what? Atmosphere. And it normally extends up to the height of what? 10,000 kilometers. Right. See, generally, when I talk about atmosphere, either you call it as 10,000 kilometers or you call them as 1,000 kilometers, it doesn't matter. Because even if I take 10,000 kilometers from the surface of the earth, if I just take it to 10,000 kilometers, my dear friends, first 32 kilometers itself, 99% of atmosphere is over. Remaining all this, what I have is only 1%, immaterial, right? Whatever it is, right? The layer of air that surrounds the earth is called as atmosphere. Everything is fine. Now here, when I just talk about this evolution, when I talk about evolution, how exactly this atmosphere came into existence, it was a process called as degassing. Proto-Earth, not today, proto-Earth, when Earth was about to form, right? Somewhere you would have studied about something called as nebular hypothesis, where the proto-Earth had its formation. Entire Earth was one ball of magma, right? Somewhere when the proto-Earth was a homogeneous mixture of magma. Somewhere, say for example, it resulted in a mechanism called as sorting. All heavy elements started descending towards the bottom of the earth and light elements started ascending towards what? The surface of the earth. That's how even today, when I talk about the earth's interior, I'll be finding one thing. Right? As I increase the depth, the density will increase, the temperature will increase. Core is the heaviest layer and crust is the lightest layer. Why exactly such an arrangement? It's because of sorting. Extension of sorting, what happens? Light elements, including the gas, started reaching towards the surface. Post reaching the surface, it started escaping. But escaping gas was retained back by the gravitational attraction of Earth. Okay, that retained gas is what today you call them as what? Atmosphere. We call them as atmosphere. The very first stage in the evolutionary process came in the form of degassing. What led to the formation of atmosphere is what? Degassing. Number two, my dear friends, water vapor is the most commonest gas that escapes. Even today, whenever volcanic activity takes place, the most commonest gas that escapes is what? Water vapor. Right? So water vapor will go for condensation. Condensation will be resulting in what? Precipitation. See how exactly lithosphere had its formation, landform had its formation. Everybody has a proto-earth was one ball of magma. Slowly, steadily, it started cooling down, solidifying. At one point of time, magma solidified, rocks, landform formed. But from where the oceans of the world came from? Degassing. The most commonest gas that ejected was water vapor. Water vapor, when it went for condensation, resulted in precipitation, and the continuous precipitation has resulted in the ocean. The earliest ancient ocean, we call them as what? Panthalassa. Then came Stati Sea, and today we have different oceans. Okay, condensation is very, very important. My dear friends, only at the third stage, we had the development of free oxygen. Primordial atmosphere, when the earth was, say, for example, somewhere when the atmosphere had its formation, what was dominating was what? Carbon dioxide. What was minimal was what? Oxygen. Oxygen was near completely negligible. Only traces where oxygen was there. Even if the examiner claims that no oxygen is there, we can take it. Okay. What was dominating along with other gases, methane and others? Carbon dioxide was dominating. Oxygen was very trace, right? Very limited. But today, what has happened? Today, what has happened? Carbon dioxide level as, see, I'm comparing primordial atmosphere and today's atmosphere. Carbon dioxide content has decreased, whereas oxygen content has increased. Now see, both. In a way, somewhere I understand. What has reduced the atmospheric carbon dioxide was also primarily responsible for increasing the oxygen level in the atmosphere. Can you tell me what exactly that process is called this? Same process. One side it will be reducing the atmospheric carbon dioxide. Another side it will be increasing the oxygen supply in the atmosphere, to the atmosphere. Name one process which can do both simultaneously. Very good, very good. Photosynthesis. Just want to tell you, life on Earth played a very important role in almost modifying the composition of this atmosphere. Very good. Photosynthesis. You got it. Particularly, see, when I say life, flora played a very important. Plant community as such played a very, very important role. And that's the reason. See, for entire evolutionary stages of the atmosphere, if you ask me, today I have oxygen somewhere almost occupying 21% of the atmosphere, which is one of the highest in the evolutionary stage. Okay. Okay. Whatever is the case, my dear friends, with the simple details, somewhere if I'm just taking you to solve one question, previous year's question. Okay. See you. In examination, if I know a statement is wrong, mark it wrong. If I know a statement is right, mark it right. If I do not know, circle it. Don't take a decision. Okay. Now, statement one. The Earth's magnetic field has reversed every few 100,000 years. Even examiner is not so clear. Okay. He's using, say, for example, both words like every and few. Is not so clear. Okay. Assume that, okay, I do not know. I'm not very sure about the statement one. I'm reading statement two. When the Earth was created more than 4,000 million years ago, there was 54% of oxygen and no carbon dioxide. Tell me the validity of this statement. Is this statement right or wrong, my dear friends? Statement is wrong. Absolutely. What you said is perfectly right. The statement is wrong. Why? Because oxygen was trace, but they're saying 54. 54 means majority, right? Never in the past we had that much of oxygen. What we have today is one of the highest level of oxygen. But their primitive atmosphere, primordial atmosphere had no oxygen or traces of oxygen, right? Here itself they say it is wrong. Okay. And see, and they're integrating the statement by this word called as and. And means what? When they're using this word called as and, this should also be, say, for example, right. And this should also be right. Only then the statement will be what? Right. Right. Even if one is wrong, my answer will be what? Wrong. But here, the case, both the statements are both. This is also wrong. This is also wrong. What was dominating was what? Carbon dioxide. Even, I'll show you this NCERT for a minute. Even NCERT says beautifully. See, they're talking about evolution of atmosphere NCERT. Okay. They're talking about, say, for example, the first stage is marked by loss of primordial atmosphere. Second stage, hot interiors, everything is fine. Finally, the composition of atmosphere was modified by the, okay. The composition of the atmosphere was modified by the living world through the process of photosynthesis. Even you said it. I asked you, you said it. Okay. Now, on the other hand, they also say that what exactly this primordial atmosphere was largely composed of. Okay. They say, when they talk about, say, for example, the early atmosphere largely contained water vapor, nitrogen, carbon dioxide, methane, ammonia, and very little what? Free oxygen. Even NCERT statement. They say what they contained more is carbon dioxide. What was very little is what? Oxygen. But what exactly statement says? Examination, they have given a statement saying that exactly other way around. Okay. That's what I want to say. Even if you can identify one statement wrong, because it is integrated by this word called as and, two is wrong. If I start removing 2 from my answer, right, wherever 2 comes in, right, what I have is only what? Option between A and C. Now see the difference, see the beauty here. I do not know about 1, but according to the given option, 1 is automatically right. So there is nothing to worry about 1. What decides my answer is what? 3. You read this third statement and tell me what is the answer. When living organism originated, they modified the early atmosphere of the Earth. Answer to this question is yes. Very good. You got the answer. Answer to this question is yes. Here, the living organism also includes what? Flora, right? They're talking about the process called as what? Photosynthesis. Okay, good. Right, my friends. Now, what I want to tell you, sometimes directly the words from NCERT I can answer. See, I understand. Last year and last to last year, NCERT happens to be the source of question. But otherwise, I strongly believe no textbook, I can say that this is the source of question. But textbook can also always be a source of knowledge. Okay. If not the same lines is asked from NCERT. See, geography, I would always say that NCERT is the best. Right? 4 books of NCERT, class 11 and 12. Right now, you read only 3. Right? Fundamentals of Physical Geography, class 11. India Physical Environment, class 11. India People and Economy, class 12. Fundamentals of Human Geography, right now you leave it, not needed. Okay? Right. Along with it, 1 chapter of GCLM, the very first chapter of GCLM. There your geography requirement is over. Okay. Right, my friends. Now, you know what is atmosphere? Before getting into it, what is very important, my dear friends? Composition and structure of atmosphere is very, very important. Okay. Now here, composition, what exactly this atmosphere largely composed of? What are the major constituent, minor constituents? Somewhere I feel that you know it. Okay. What I want to somewhere tell you, what are the different gases or the constituent in atmosphere which plays a very important role in somewhere modifying the climatic patterns, right? Or somewhere influencing the climate you should. For that, it is very simple. Major constituent, all the major constituent you take it, they are inactive. Any minor constituent you take it, they are active. What is very small, they are active. What is very large, they are not active. Means they do not determine any, say for example, they do not influence the climate as such. Okay. Now, assuming that you know the composition, I would recommend that you also know the structure of atmosphere. I already told you this atmosphere extends to the height of 10,000 kilometers. 10,000 kilometers. And I have different layers. Depending on, say, for example, nature and character of each and every layer, I can demarcate. Okay. So the lowest layer, you call them as what? Troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Maybe if you want to read it in order, I would say trust me in the exam. What is this trust me in the exam? Very simple. The lowest layer is troposphere, followed by stratosphere, followed by mesosphere, followed by thermosphere. Thermosphere can sometimes also overlap with ionosphere. IN is ionosphere, TH is thermosphere, and EX is what? Exosphere. This is the layers, different layers what we have. Whatever I call it as. Among the different layers, the smallest layer is troposphere, but the densest layer is also what? Troposphere. The most important layer is troposphere. Troposphere is called as weather layer of, right? And my dear friends, I already told you, though I treat atmosphere taken till the height of 10,000 kilometers, first 32 kilometers alone, I have 99% of atmosphere by mass. By mass. It means near complete atmosphere is over. Remaining distance is just a formality. Okay. Now here, thermosphere, troposphere is the weather layer. Whatever changes that is taking place in atmosphere is troposphere. To some extent, stratosphere can also influence the climatic aspect. See, whenever I say climate or weather, my dear friends, I am not talking about the entire atmospheric condition. I am talking only about the condition of which layer? Troposphere. Okay. Now here, troposphere is a very important layer, as I said. Okay. Now, the only layer which do not have uniform height is what? Troposphere. Troposphere, where exactly I'll be having the maximum height if you ask me. Maximum height is recorded over what? Equator. Even in this diagram I have just mentioned here, maximum height is 18 kilometers. Where? Over equator. Minimum height is 8 kilometers. Where? Over the poles. Now comes one question. Why? Okay. This layer alone do not have uniform height. And one more thing. Any layer, the uppermost limit, we call them as a pause. Troposphere upper layer, limit up tropopause. Stratosphere limit, stratopause. Mesosphere limit, mesopause. Okay. Now here, my dear friends, as I already said, they do not have any uniform height. Minimum height over the poles, over the equator, and minimum height over the poles. Now comes the question, why? Causative factor. Very simple. Equatorial region, what will be the temperature? Throughout the year, equatorial region will experience high temperature. If temperature is very high, what will happen to the air mass? Air mass will get heated up. Air mass will get expanded. Air mass will become light intensity. So take it, wherever there is warm air mass will start rising. So this rising air mass will be pushing this tropopause level. It will be pushing this tropopause level. Okay. Whereas on the other hand, it is exactly opposite. Polar region, what happens? Temperature is cold. Cold air mass will be descending, subsiding. Subsiding air mass will be pulling the tropopause level somewhere from its original location. Whatever it is the case, if you ask me what is the average thickness, I can take it as what? 13 kilometers. Not only here, between summer and winter also this will change. This will change. Okay. India, over summer, tropopause level will be, or troposphere thickness will be more. Winters it will be less. Okay. Wherever air mass rises, wherever there is a rise, vertical movement of air mass, we call them as convection. Wherever air mass is rising, there all the tropopause level will be. Wherever air mass is subsiding, there all the tropopause level will be less. Okay. Now here, the small piece of information. somewhere if I'm just solving this previous year's question. Okay. You just read the statement. Second question. Last year paper, 2024 paper, direct downloaded from the website itself. UPSC paper. Thickness of troposphere at the equator is much greater compared to the poles. The statement one, right or wrong alone, you tell me. One by one we'll go. Statement one, thickness of troposphere at the equator is much greater as compared to poles. Statement one is correct because I know right at the equator it is 18 kilometers, poles it is 8 kilometers. Statement one is correct. Now individually, right? Forget about the reasoning. Statement two, at the equator, the heat is transported to great height by strong convectional current. Whenever I use this word called as convection, vertical movement of air mass, climatology, we call them as what? Convection. It means statement two is also correct. Now, only if statement 1 and 2 is correct, then I have to go for this, say for example, causative fact. Both you try to integrate by this word called as because, right? And see whether it is making a meaning. Thickness of troposphere at the equator is much greater as compared to the poles because at equator, heat is transported to a greater height by strong convectional current. If because makes a meaning, then your answer is A. If not, your answer is B. You tell me which is the best answer here. Good. Most of you already gave me the answer. Very good. Answer to this question here is what? Okay. Again, NCERT, again, you take it directly, it is given. Only I'm just telling you what exactly is the logic. See, climatology, last year, this is, first question is geography. Second question is geography. Third is geography. Fourth is geography. Fifth is geography. Question number 6 is geography. 7 is geography. 8 is geography. 9 is geography. 10 is geography. 11, okay. 11, I don't purely see it as a geography question. Okay. You take it as current affairs question, nothing wrong. 12 is geography, pure geography. 13 is pure geography. 14 is pure geography. 15 is pure geography. Right? Global emission, climate of the region, world's tropical peatland. Okay. 16, I can take it in geography as well as in environment, whatever it is the case. But other questions, it is purely geography. Then again, say, for example, inside the papers also, we have few geography. Last year, 22 questions were asked from geography. That too basically from NCERT. And see, generally, I have this belief. I may be wrong, but still, whenever technology increases, whenever there is a sudden spike in the technology, I am talking about AI. AI is not available to everybody. Am I right? India is divided at least digitally. Okay. We call them as a digital divide. But somewhere I feel that, say, for example, UPSC gives a level playing field for everyone. Somewhere, definitely speaking, UPSC will not punish those students or aspirants who will not have an access to the technology, particularly AI-based technologies. If that is the case, whenever there is a spike in the technology, I always feel that UPSC will be going back to the basics. Going by this logic, this year also, I feel that more NCERT questions can be surfacing in the paper. So all value additions you do, right? All value additions you can do, but after covering NCERT extensively. Okay. Right, my friends. Now, getting back the question again, or the topics. Fine. When I just talk about, say, for example, troposphere, everything is fine, right? Whether layer of the earth, largest layer by the mass, smallest layer by the volume, given the case, it is the densest layer. But now see, when I just talk about the troposphere has one, I would say it is the most important property. What is this important property? As you increase the height, the temperature decreases. For example, plains and mountains, if I'm just comparing, I find plains will be warmer, hills will be colder. That's the reason, say, for example, Britishers have started this climate, right? Winter capital and summer capital. Even today, you will be finding that whenever the people are there in the plains, that too, say, for example, people haves and have nots. Okay, haves, whatever it is. Summers, you will not find them in plains. They'll be somewhere settling in what hill stations. Somewhere, say, for example, started with British legacy. Why? Because I know the fact that mountainous region will be colder and the plains will be warmer. Why? Because it is largely because of this character of this troposphere. You increase the height, temperature decreases. This character property of this troposphere, you call them as what? Normal lapse rate. For every 1 kilometer of increased height, you increase the height, the temperature will decrease by 6.5 degrees centigrade. Or NCRT data, it says, every 165 meters of increased height, the temperature may decrease by 1 degree centigrade. Whatever it is the case, increase the height, temperature decreases. Now comes the question, how or why? More than how, let me call us why. Why? It is very simple, because my dear friends, when I talk about atmosphere, one thing is very, very important in my understanding. How this atmosphere is heated up. Is this atmosphere heated directly by sun's rays? Answer is no. My dear friends, the energy comes from the sun. We call them as insolation. For insolation, this atmosphere is largely a transparent medium. I'm not saying completely transparent. It is largely a transparent medium. It will be somewhere penetrating the atmosphere. It will be striking the surface of the earth and it will be heating up the surface of the earth. So insolation will be primarily heating up the surface of the earth. And that heat, which is eventually liberated from the surface of the earth in the form of terrestrial radiation, in turn will heat up the atmosphere with the help of greenhouse gases. Okay. Now, what I want to tell you, when I just talk about the primary source of atmospheric temperature or the direct source of atmospheric temperature, instead of primary, I'll use this word direct. Right? Atmosphere is not directly heated up by insolation. Atmosphere is heated up by what? Terrestrial radiation. Now you may ask, how come insolation is not heating? Only terrestrial radiation is heating? Because the nature of the, say for example, almost this wave itself is different. Insolation is a short wave radiation. It is a short wave radiation. It is an infrared radiation. Sorry, excuse me. It is an ultraviolet radiation. It is short wave or ultraviolet. When talk about terrestrial radiation, it is long wave or infrared in nature. Okay. And that too, terrestrial radiation do not heat up the atmosphere directly. This is the place where greenhouse gases comes in. If greenhouse gases would have not been there, certainly speaking, even terrestrial radiation would have not heated up what? Atmosphere. Plenty of greenhouse gases are there, but the mother of all greenhouse gases, the gang leader, comes in the name of what? Carbon dioxide. Okay. So what I want to tell you, my dear friends, atmosphere is predominantly heated from the bottom, not from the top. At least this logic is applicable till mesosphere. One small exception comes in stratosphere because of ozone's presence. But otherwise, till mesosphere, atmosphere is largely heated up from the bottom. Right? The rays means somewhere, say for example, the surface of the earth act as that source of heat from what? The atmosphere. I repeat again, the statement is very, very important. Atmosphere is largely heated up from the bottom. And that too by what, if you ask me? That too by terrestrial radiation. Okay. If that is the fact, what I can take it. Again, I am going back to a previous year's question, 2024. See, few paragraphs, few topics we are discussing. How many questions? I am going in a linear model, right? How many questions asked in single paper, right? Thickness of troposphere, just now we have taken it, right? Okay. Very first question, right? Two statement, you just read it, my dear friends. The statement one, first question, statement one, what they say, atmosphere is heated more by incoming solar radiation than by terrestrial radiation. The statement one, you say whether it is right or wrong. Statement 1 itself is what? Wrong. Why statement 1 is wrong? For the simple reason, atmosphere is largely heated from terrestrial radiation. What they are saying is other way around. My dear friends, if statement 1 is wrong, is it necessary for me to read statement 2? Tell me. Is it necessary? Actually, it is not. If statement 1 is wrong, if you're very confident, if you're super confident that the statement 1 is wrong, I directly got the answer. My answer is D. Right? Because this is one type of a question where I will not have both the statement. Okay. So directly I can say, for example, take it, I can say that my answer is D. Statement 1 is incorrect, but the statement 2 is what? Right. Okay. Okay. Going back to the topic as such. Now say, for example, yes, we talked about troposphere. Then when I talk about stratosphere is an exception. Unlike troposphere, stratosphere, you increase the height, temperature also increases. We call it as a temperature inversion. We call it as temperature inversion. And it is largely because of the presence of ozone. Presence of ozone, because ozone is the first level of filtration. Generally, we say, right? Ozone filters harmful ultraviolet radiation. My dear friends, the so-called harmful ultraviolet radiation is nothing but insolation. The statement simply says ozone absorbs insolation. That's all. Okay. Nearly what percentage, if you ask me, ozone absorbs the 14% of the net insolation. It cools down. It cools down. All the insolation that comes to the earth as a system do not reach us ultimately. That's the reason we say wherever there is a ozone hole, exposure to this insolation is exposure to the harmful ultraviolet radiation is. Okay. And my difference, one thing is there. Troposphere, very, very important. I do not tell you. This normal lapse rate, very important. This normal lapse rate is primarily responsible for facilitating the process called as condensation. Normal lapse rate plays a very, very important role in the formation of what? Clouds. If normal lapse rate is not there, what I will not find generally is what? Clouds. Stratosphere is relatively free from what? Clouds. And that's the reason stratosphere is the most preferred layer for aviation sectors, flights, right? Because turbulence will not be more, friction will be less, fuel efficiency will be more, and so on. So many other, say, for example, things are there. Okay, right. Right, but even stratosphere, we do have a mesosphere, nothing much. It is more like troposphere. Ionosphere is very interesting, but mains question last year, 2024, mains question they have asked. Ionosphere, electrically charged layer. And this is a layer where you'll be finding one most beautiful phenomena called as aurora. Because this is an electrically charged layer, thermosphere. Either you call them as thermosphere or you call them as what? Ionosphere. One small clarification. When I say thermosphere and ionosphere, what is the difference? Till 400 kilometers, I can take it as ionosphere. Till ionosphere. Right? If I take it till 700 kilometers, I can take it as what? Thermosphere. It means what? 80 kilometers to 400 kilometers is ionosphere. 80 kilometers to 700 kilometers is thermosphere. It means 80 to 400, it is both ionosphere and thermosphere. Beyond it, it is only thermosphere. Ionosphere is an electrically charged layer. This is a place where I have this magnetosphere, right? Whenever this electrically charged spectrum from the sun, you call them a solar flare or solar waves, whatever it is the case, right? Solar wind, you call it as a solar wind. Whenever the solar wind, with the charged particles enters the Earth's atmosphere, we're already having charged particles in the atmosphere in this layer. And both these charged particles goes for a collision. That collision will be producing a light, kind of a laser light show in the sky you'll be having. That light produced, you call them as what? Auroras, right? Right, my friends. You call them as polar lights. Why auroras is called as a polar light? Because auroras occurs only in the polar region. Again, I should not use this word called as only, right? I'll not use it because very recently, even India, we experienced it. Any idea? Which state in India we have seen this auroras? I should say more than state, I should say union territory. Generally, auroras are confined to polar region. Arctic region, it is very, very common. Norway, Sweden, Finland, right? All these places, it is very, very common, right? But India, very interestingly, we happened in one region. Good. Ladakh. Experienced, say, for example, this aurora in Ladakh. Okay, fine. But why in polar region it is very common, if you ask me, very simple. Whenever this electrically charged particle enters Earth's atmosphere, they generally gets deflected towards what? The polar region. Because polar region is the place where I'll be having strong magnetic field. Today, I have something called as north magnetic pole and south magnetic. Today, where exactly this north magnetic pole is located? Any idea which country? North magnetic pole, my dear friends? Good. Canada. You're there in Canada. There is an island called as Queen Elizabeth Island. Okay, that's a place where I have this north magnetic field. Okay, whatever it is the case. Geographic north is different. Geographic north pole is different. Magnetic north pole is different. Because today I have this magnetic poles in, say, for example, very near to the polar regions. I'll be having this attraction of this solar wind towards what? Okay. So the polar lights of the northern hemisphere, we call them as what? Aurora borealis. And the southern hemisphere, we call them as what? Aurora australis. Northern lights and southern lights. Why australis? Because from Australia, the southern parts of Australia, this phenomenon is visible. Why borealis? The forest, what you see in the backdrop, you call them as a taiga forest or you call them as what? Boreal forest. Okay. You call it as a boreal forest. There is a reason. Right, my dear friends. Now, this is all about this structure of atmosphere. Now, see here, I have given you the temperature variation in different layers. What happens? Troposphere, the temperature decreases with increasing height. Stratosphere, temperature increases with increasing height. Mesosphere, it decreases. Thermosphere, it increases. Now, a few points that has to be taken from this diagrammatic representation. Entire atmosphere, okay, let me ask you. Entire atmosphere, according to you, where exactly the maximum temperature will be recorded? Which layer? 5 layers of 5 layers over there. You tell me which layer the maximum temperature will be recorded. Name itself gives you. Geography is one subject where name gives you. Maximum temperature. Maximum means this temperature is very warm. This layer is very warm. Thermosphere. Name itself gives you. It is thermosphere. Very good. On the other hand, where the minimum temperature will be recorded, very interestingly, it is at mesopause level. Mesopause level. Okay. Mesosphere, mesopause level. Very, very important. Okay. And similarly, one fact I did not tell you, entire atmosphere I told you. Minimum temperature, mesopause level. Maximum temperature, thermosphere. But my dear friends, just coming back to this troposphere. Troposphere is very important. Troposphere, the weather layer of the earth, you call them as what? Troposphere. Okay. This weather layer, my dear friends, right? Where exactly the minimum temperature will be recorded in entire troposphere, if you ask me, very interestingly, it is at the tropopause level over equator. This fact, kindly make it as an important point. Most of you will be knowing it, but still I'm just entire, say, for example, troposphere, the minimum temperature will be recorded at what? Tropopause level over equator. Okay. So with this, the structure of atmosphere I've just completed. Okay. See, kindly excuse me. Again, I need 10 minutes break. And all the break, I'll be compensating it. Okay. Right. I'll take 10 minutes break with your permission. I'll just come back. Totally, today we are scheduled for 4 hours. Already, I've just given you one 15 minutes break. Now I'm just taking one 10 minutes break. We'll extend till 8:25. Right. Coming back to our discussion. Right. Here, the structure of, say, for example, this atmosphere we have just done. Now here, entire climatology as a chapter, how exactly it goes if you ask me. After talking about this general structure of this atmosphere, we have to start with this forward linkages of this chapter, right? First, insolation. Then we'll be talking about this distribution of insolation, followed by temperature and its distribution. Then we'll be talking about the pressure system. Then we'll be talking about wind, and we have to talk about climate. Okay, general gist. See, when I just talk about insolation, what is insolation? Generally, we say insolation is the trace amount of heat that Earth as a system receives from the sun. You call them as what? Insolation. And this insolation varies from place to place and time to time. Okay. Now here, the amount of heat received from the sun. Simple. Make it very simple. Amount of heat received from the sun is called as insolation. Almost this amount of insolation is almost constant throughout the year, barring some exception. To be very precise, nearly all 365 days, this amount of insolation will be more or less similar. But 1 or 2 days, it will be slightly higher than the normal, or it is slightly less than the normal. Okay. You ask me, okay, I am asking you, my difference. Any day, heat received from the sun by the Earth, you call them as one insolation, right? Can you tell me, I'm talking about the entire Earth, forget about the hemisphere, right? No northern hemisphere, no southern hemisphere, entire Earth I'm just talking about. Any idea? Which day the insolation received will be more and which rates it will be less? Okay, normally I say, okay, this day of the year, insolation received by the Earth will be more, and this year it will be less. Any idea? Very good, fantastic, Mike, good. Perihelion. There is a position called as perihelion and aphelion. When sun is very close to Earth, we call them as perihelion. When sun is far away from the Earth, we call them as what? Aphelion. Okay, now say for example, here. We're talking about this perihelion and aphelion. When sun is very, very close, you call them as what? Perihelion. On this day, the distance will be somewhere around only 147 million kilometers. Okay, only 147 million kilometers. When I just talk about, say, for example, aphelion, far away, the distance will be somewhere around 152 million kilometers. Okay, perihelion and aphelion. Okay. And my dear friends, when exactly perihelion will be occurring? Almost every year it will be occurring approximately on January 3rd. Aphelion will be occurring somewhere around July 4th. Plus or minus 1 day is always accepted. Okay. It can occur on January 2nd, January 4th, whatever it is the case. Okay. Now here, where exactly I'll be? What is perihelion and aphelion? On the perihelion day, assume that on every average day, insolation received will be 100%. On the day of perihelion, it will be 103%. On the day of aphelion, it will be 97%. Marginal variation will be there. But this marginal variation is sufficient enough to cause what havoc? Particularly, which, say for example, country, say for example, will be somewhere getting affected by the combinational factor of both perihelion and, say for example, it's a respective summer. If you ask me, I'll say Australia. Or I should ask you this question. I'll take the case of Australia, right? I've just taken the case of Australia. You find something very interesting when it comes to Australian cities, particularly human settlement pattern. You find Australian cities are very, very unique. Most of the cities in Australia, you'll be finding they are located along the coastal margins. Coastal margins. Any city you take it, you'll be finding it along what? Coastal margins. Okay. Hardly I'll be finding few human settlement in interiors. Okay. Kalgoorlie, middle of desert, but gold rush. It is known for Kalgoorlie, right? And I would say, for example, Alice Spring, it is all because of artesian basins, right? Mount Isa, again, I understand, say, for example, elevated region, mountainous regions are there. Otherwise, what I understand, interiors of Australia is highly deserted. Now, if I ask you a question, why human settlement in Australia or why cities in Australia is located along the coastal margins? What can be the reason? Cities or coastal cities, what can be the reason? Maybe, okay, I'll tell you the reason. If you ask me why, what exactly, why coastal cities in Australia are located only in the coastal region, if you ask me, because I would say Australian summers are very harsh. I call it as harsh summers. Harsh summer. Every year, Australia is known for bushfires. We call it as forest fire. Australia calls it as a bushfires. Then you may wonder if Australian summers are very harsh, why only to the coastal areas? Because I understand water maintains what temperature. Fluctuation of temperature and water is not so great, right? It will be moderate somewhere in the coastal areas, right? Comes under the influence of the ocean. The relative humidity will be more. Moisture content of the air mass will be more. Fluctuation of the temperature will be less. Coastal cities will not become too hot. Coastal cities will not become too cold. Finest example, Chennai and Delhi, if you take it. Summer, Chennai maximum 41, 42. Delhi crossed 50. Very easily it crossed 50. Chennai 40 means end of the world. Okay. Delhi has crossed 50. 50 means, say, for example, something unimaginable. Right? Without the gas stove, you can say, for example, you can cook outside your, say, for example, doors. That is 50 degrees. Okay. Winters. Places like Chennai will be somewhere around minimum talking about 20, right? Maximum 20 or, okay, I should say minimum 20, 22. Delhi sometimes sub-zero condition. See the difference, 0 to 50. Chennai is only between 20 to 40. Why Chennai oscillation is less, Delhi oscillation is more? Coastal areas. Coastal areas, temperature will be maintained. Okay, fine. Coming back here. Why only coastal areas or why only cities are located in the coastal areas in Australia? Very simple. See, any modern cities you'll be finding in the coastal areas, ancient cities you'll be finding along the riverine banks, perennial roads. Any civilization you take it, ancient civilization, right? Fertile plains of some roots, river valley. Even you call them as what? Indus Valley, right? Civilization, correct? Will be mostly. Exceptions are always there. Any modern cities, coastal areas. That's where, say, for example, people started traveling. They got settled down somewhere after discovering the new lands as such. Even USA, North America also, you take it, coastal areas will be more populated. But what I understand, initial settlement has happened in the coastal area. Slowly, steadily, population started traveling inside. But Australia, that doesn't happen. For the simple reason, again, I would say Australian summers are very harsh. Now comes the major question. Why Australian summers are very harsh? Why Australia is prone to forest fire every year, almost. That too, if El Nino is there, forest fire is for sure. Bushfires, they call it as. Now you tell me, my dear friends, why Australian summers are very, 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 very harsh? Coastal areas, you may not find it. Whenever I say summers are very harsh, I'm talking about the interiors. Interiors of Australia. Okay, considering the time, I'll tell you. Because Australia, when exactly Australia experienced summer, if you ask me, Australia is there in the southern hemisphere, correct? If that is the case, Australia, they experience during what? Summers they experience during month of December and January, right? Now what happens? Okay, good, very good. So I got the answer. Australia, whenever they're using, means experiencing their peak summers in the month of December and January, that is the same time when the Earth also experiences this position called as what? Perihelion. Already it is summer in Australia. Huh? January 3rd, for us it is winter. Australia is southern hemisphere summer. Already it is there in, say, for example, summer in Australia. But along with that, what I understand, Australia additionally also experience what? Means entire Earth is experiencing what? Perihelion condition. So insolation amount received itself will be what? Right? So the summer is intensified by perihelion position. That is why Australian summers are very harsh. Why not the other countries of the southern hemisphere? Because southern hemisphere, we do not have that much landmass. The only considerable landmass what we have is Australia, right? Otherwise, even Africa, to some extent, we have in the extension of what? Southern hemisphere. South Alps, when I talk about America, I have the tall mountains and the tapered land. So only significant landmass what I have is Australia. That too running through Tropic of Cancer or Tropic of Capricorn, sorry, runs through Australia. Put it everything together. Okay. And summer associated with perihelion, temperature happens to be what? On the higher side. Okay, now comes the question. When I talk about this insolation distribution, from time to time and place to place insolation distribution will be different. In that way, my dear friends, What determines this distribution of insolation? Right? Particularly, right, we talk about angle of insolation, angle of sun's rays. At what angle the sun's rays is, right? Higher is the angle of sun's rays, energy will be concentrated. Lower will be the angle of sun's rays, energy will be distributed. Even in a single day, I can take it. When sun is rising, temperature is not so great. When sun slowly, steadily climbs in the sky, during the noon time, temperature will be very high. Why? Concentration of insolation. More the angle, more the insolation. That's the reason we say angle of sun's rays plays a very, very important. Why lower latitudes are always warmer? Because throughout the year, what I'll be having is high sun position. Why higher latitudes are always colder? Because I'll be having low sun position throughout the year, slanting sun's rays. Okay. Because see, energy carried by the sun's rays is same. But where comes the difference is the area of its distribution. Concentrated energy versus a larger area is what distributed energy, angle of sun's rays. Number two, along with the angle of sun's rays, right? It is the distance traveled by sun's rays through atmosphere. For example, normally, if I just take this atmosphere, my difference, what I understand, vertical sun's rays will be traveling the minimum distance, whereas slanting sun's rays will be traveling what longer distance. Longer is the distance traveled by sun's rays through atmosphere, more will be the loss of insolation. By the time the slanting sun's rays reaches the surface, it will be a faint rays. It will be largely devoid of what? Energy. Okay, right? So point number one and point number two are very, very important. Number three, apart from that, I can also talk about the length of the day. Summer, normally what happens? Length of the day will be more. So the period of absorption of insolation will be more. Winters, shorter days, period of insolation, right? Exposure to the sun's rays itself is what. Okay. These are various factors which will be influencing the temperature as such or insolation as such, for example. Apart from that, though I have not covered here, I can also talk about what? Transparency of the atmosphere. If atmosphere is more transparent, insolation received by the surface of the earth will be. If atmosphere is less transparent, the loss will be. Okay. That I'll be giving you more, say, for example, ideas in this. Another topic called as heat budget. See here, one thing is there. This topic we call them as atmospheric temperature. Let me call it as heat budget. Budget, I understand, right? Balance between what is incoming and outgoing, we call them as budget. In economic terms, when I call it as budget, the balance between income and expenditure, you call them as what? Budget. Now here, what is incoming is what? What is coming inside the earth is insolation. What is outgoing is what? Terrestrial radiation. The balance between incoming solar radiation and outgoing terrestrial radiation, we call them as what? Heat budget. So somewhere this heat budget gives you a rough idea that what are the constituents in atmosphere will be influencing the temperature. What may reduce the temperature and what may increase the temperature. In that way, very crude example. Assume that I say, for example, I assume that 100 units or 100% of insolation comes to the surface of the earth. 100%. Okay. Right. In this 100%, already I told you, ozone absorbs 14%. In this diagram, I have used symbols like plus. Plus means absorption. Minus means losses. It is loss. Okay. 14% is absorbed by ozone as a layer, stratosphere. Okay. What comes to troposphere is only 86%. In this 86%, 6% is reflected by what? Somewhere scattered, to be very precise. That's the word of what I use. Scattered by aerosol. All suspended solid particles in atmosphere, dust particles, pollen grains, volcanic ash. That's the reason, my dear friends. Generally, we say, okay, let me ask you this question. Of course, you'll be answering it. All of a sudden, if the number of volcanic activity increases in the world, right? All of a sudden, volcanic activity is increasing in the world. More dormant volcanoes are becoming active, right? Say, for example, magma is coming out, volcanic ash is coming out, everything is coming. What will happen to the temperature? If all volcanic activity, all of a sudden, if it is increasing, what will happen to the global temperature? Will the global temperature increase, or it will be decreasing, or there is no change? Very good. Very good. Most of you got it right. Temperature actually decreases. Why temperature decreases? Very simple. The temperature decreases because volcanic activity will be somewhere, say for example, emitting volcanic ash. Volcanic ash will be acting as aerosols. Aerosol will be scattering insolation. Thus, it will be reducing the temperature. Okay. That's the reason normally when pollution in the atmosphere is also increasing, the temperature will decrease. Aerosol. So aerosol will be scattering what? The sun's rays or insolation as such. 86 is gone. Remaining what is 80? Out of this 80, 27% is reflected by cloud. It will be acting as an albedo. Any reflection of insolation, you call them as albedo. Right? In 86, 27, sorry, 80, 27 is gone. What comes to Earth, touches the Earth, is only 53. Out of the 53, my dear friends, 2% is reflected by what? Ice caps. Not only ice caps, surface of the Earth, whatever it is the case. Okay. Whenever insolation is reflected, cloud reflects insolation. Ice caps reflects insolation. Whenever this insolation is reflected, the same we call them as what? Albedo. Right? What determines the albedo factors is the color and the smoothness of the surface. Okay. Now, what I want to tell you, all taken away. Right? What is absorbed by the surface of the Earth is only 51%. Nearly half of the insolation alone finally reaches the surface of the Earth and it is being absorbed. And my dear friends, see here, what all is reducing insolation? See, aerosol is reducing insolation. That's the reason I say volcanic activity, if it increases, temperature will decrease. Aerosols. If pollution level in the atmosphere increases, temperature decreases. Aerosol. Day after Diwali, temperature decreases. Aerosols. Correct. When cloud cover is more, again, what happens? Cloud during the daytime, not during the night time. Cloud during the daytime will be decreasing temperature. Reflection. Why equatorial region, in spite of the fact experiencing high angle of sun's rays throughout the year, right? If you ask me, different regions of the world, which region experience on an average maximum angle of sun's rays, it is equatorial region. But very interestingly, equatorial region is not the hottest place on the earth. Hottest place on the earth is located along the tropical region. Why not equatorial? I'm asking you this question. In spite of the fact it is experiencing highest sun's angle, why equatorial region do not experience the maximum temperature? What is the reason? Okay. Very good. Very good. It is cloud cover, my dear friends. It is the presence of permanent cloud. See, it is raining every day. Again, if you ask me why raining every day, because it is cloud cover. Almost it happens. Almost it rains every day. More than 300 days in a year it rains. Right? The wettest climate of the world, equatorial region as such. Cloud cover. I said global average is 27%, but equatorial region is more than 40%. Cloud cover. Permanent cloud cover is the one which makes equatorial region not the, say for example, hottest place of the world. Okay, cloud cover. Ice caps. Polar region plays a very important role. Greenland ice caps plays a very important role. Alpine glaciers, mountain glaciers plays a very important role in determining what, or somewhere reducing what temperature. See, my dear friends, tomorrow, if all the glaciers in the world is deglaciated, somewhere I know, global temperature, increase in the temperature will be resulting in what? Deglaciation. Deglaciation. That is okay. That everybody knows. Global warming, increase in the temperature. I'll use this word called as global warming. Global warming will be resulting in deglaciation, that everybody knows. But what is very interesting, deglaciation will further aggravate global warming. It will further increase the global temperature. How and why, if you ask me, very simple. Tomorrow, if all the glaciers are removed, the net insolation absorbed by the earth will not be 51 anymore, it will be 53. In that way, it will be increasing. Okay. Fine, now coming to terrestrial radiation. 51% absorbed by the earth has to be liberated back. 17% directly liberated to what? Exoatmosphere. But 34% is retained back by atmosphere, right? Particularly troposphere with the help of carbon dioxide. Not only carbon dioxide, all greenhouse gas put together. And see the beauty. What is the percentage share of carbon dioxide? Carbon dioxide as of now is only having 0.036, not 0.36. It is 0.036 percentage. This is the composition of carbon dioxide, holding back nearly 2/3 of what? Terrestrial radiation. Nearly 1/3 of what? Insolation. Somewhere I can imagine. Slightly, even the slightest increase in carbon dioxide can change the complete heat budget of the Earth. That's the reason we say, for example, carbon dioxide or any greenhouse gas is what? Very, very sensitive, right? Even the slightest change can modify, right? Tremendously. Okay. Right, my friends. I've just given you an idea of heat budget. What are the different constituents in atmosphere can either reduce the temperature or increase the temperature? But also, I've just given it. So see, carbon dioxide, we say, sometimes what happens, greenhouse gas is more demonified. Somewhere it is given a picture as though greenhouse gas is very harmful, but it is very vital, very, very vital. Carbon dioxide would have not been there in this earth, the life on this earth would have not persisted. That is okay. Forget about life. If greenhouse gases would have not been there, the temperature of the earth will not be maintained. Night would have been extremely cold. For the global temperature itself, they say, if carbon dioxide would have not been there, the globe would have been colder by 33 degrees centigrade. Today, it is somewhere around 15 degrees centigrade, 15.2 degrees centigrade. If carbon dioxide would have not been there, the average temperature of the earth would have been what? Minus 18 degrees centigrade. Carbon dioxide is very, very important in maintaining what temperature and the sustenance of the life as such. Okay, right, my friends. Now, coming to the distribution of this atmospheric temperature. And one more thing, one more question. I'll look for one question. Okay. 2022 question, I thought of including it. Okay, not an issue. Good. Okay, this is one question, 2023 question. With reference to the Earth's atmosphere, which of the following statement is correct? See, some of the facts NCERT directly gives. When it comes to insolation, let me take from NCERT. Okay, see here. When it comes to spatial distribution of insolation, this is very important. Spatial distribution of insolation at the Earth's surface. The insolation received at the surface may vary about 320 watt per meter square. This is the highest. And where exactly I'll be having minimum force. And very importantly, already I told you, I've given you a clue. The maximum temperature is not recorded at equatorial region. Where the maximum temperature is recorded? Tropical region. Okay. So in tropical region, the maximum insolation what we receive is 320. Polar region, the minimum what we receive is what? 70 meters. Extension, whatever we have discussed, extension and what? NCR. This is NCRT information. If I'm somewhere able to solve this 2014 question, sorry, 2023 question. Okay. See here, they're asking you a question. With reference to the Earth's atmosphere, which of the following statement is correct? Which of the following statement is correct? It means three statement here given is wrong. Okay. First statement, you just read the first statement and tell me whether it is right or wrong. Total amount of insolation received at the equator is roughly 10 times of that received at poles. Just yes or no alone, you just tell me. Okay. It is wrong. Why it is wrong? Because see, when I talk about tropical region is maximum 320 watts per meter square. Polar region, it is 70 watts per meter square. So one thing I know, equatorial region should be less than what? 320. Even if I take it as 320, what I understand, right? Polar and tropical, it is only 4 to 5 times. But what they are giving is what? 10 times wrong. Statement 1 is wrong. Okay. Now read statement 2 or B, option B. It's not a statement, directly it is option. Read option B, my dear friends. What exactly they say? Okay. What exactly they say? Infrared rays constitute roughly 2/3 of insolation. Yes or no? One great fallacy is there. When talk about insolation, insolation is not infrared. Insolation is what? Ultraviolet. Right? Only terrestrial radiation is what? Infrared. Again, B is gone. Okay. Option C, right? Read option C. What exactly they say? Infrared waves are largely absorbed by the water vapor that is concentrated in the lower atmosphere. Infrared rays are largely absorbed by the water vapor that is concentrated in the lower atmosphere. Is this statement right or wrong? Somewhere I can encircle it. Assume that it is doubtful. If I read option D, what exactly it says? Infrared waves are part of visible spectrum of electromagnetic waves of solar radiation. Infrared is not visible. Even if I just not treat this question as a geography question, statement D, infrared is not visible. Okay. Talk about, say, for example, heat sensing camera, somewhere you'll be finding something like infrared spectrometer, you'll be using it. Okay. Now, what I want to tell you, C is the right answer. Okay. Now, here comes the question. Okay, how come? Somewhere I have a doubt. How come I say C? C is the best answer. One thing. What they say, infrared waves are largely absorbed by water vapor that is concentrated in the lower atmosphere. One thing I know, infrared rays is nothing but what? Terrestrial radiation. Terrestrial radiation is largely absorbed by greenhouse gas. The only option I have to decide, the only decision I have to take is this water vapor a greenhouse gas. If I say that water vapor is a greenhouse gas, then statement C is correct. If water vapor is not greenhouse gas, then the statement C is what? Right. Everybody knows that water vapor is one very important water vapor. Water vapor is what? Greenhouse gas. Okay. Okay. So just want to tell you that the statement C is what? Or this option C is correct. And one more thing. Normally, we look for the difficulty of the question. This question 2023 question is not so easy, but still you can solve it. Right, my friends. Now, coming to the distribution of atmospheric temperature. Insolation determines atmospheric temperature. Amount of heat present in the lower reaches of atmosphere, you call them as what? Atmospheric temperature. Okay. Now, what are the different factors which will be determining this atmospheric temperature? Plenty of factors. I'll be having latitude, altitude. See, latitude, lower latitude, insolation gets concentrated. Higher latitude, distribute. So you increase the latitude, what happens to the temperature? Temperature will be decreasing. Okay. Altitude. You increase the altitude, What will be decreasing is again what? Temperature. If you ask me why, answer is very simple. It is all because of what? Normal lapse rate. Number 3, very, very important. We are talking about Delhi, right? Delhi and Chennai. We are talking about the coastal cities of Australia. Continental. Why the coastal areas, the fluctuation is not so great? Influence of water. Very, very important. Very important. Water maintains the temperature. Fluctuation of temperature is not so great. Be it annual range of temperature or diurnal variation is not so. Very, very important. And my dear friends, even ocean currents and prevailing winds also play a very important. Even last year, I showed you one question, right? They're talking about, say, for example, how temperature is, say, for example, almost affected. How this isotherms is somewhere influenced by this ocean currents. Only 2 types of ocean currents. I'll be having cold ocean currents, I'll be having warm ocean currents. Then I'll be having something called as what? Local factors. Cloud, water vapor, aerosol, etc. They will also influence what? The temperature. See, latitude and altitude we know. You forget about it. But when I talk about continentality, I told you why coastal area maintains temperature. My dear friends, coastal area, what I understand, one thing is there. Relative humidity will be more. Okay, that way it maintains temperature. But why water? What is that nature of water? See, what I understand, the basic difference between water and land. Land is just a surface, but water is not surface. It is a volume, right? Land is just two-dimensional in nature. It's just two-dimensional. But when I talk about water, I understand, say, for example, water comes as a volume. Correct. Water comes as a volume. Now, what I understand, land, only the surface is heated. But volume, the water entire volume is heated. Okay. When I talk about land, very easily it gets heated up. Or very easily it almost loses the heat. Water is not the case. Multiple layers is getting heated. Okay. Water takes more time in getting heated up. Water also takes more time in losing that heat. In between, water will be maintaining that temperature. Right? That's the reason we say water fluctuation of temperature is not so great in water. Normally, technically, we say specific capacity or specific heat capacity of water is the energy needed to increase the temperature of water by 1 degree centigrade is more than that of what land. Water is translucent, water is mobile, and given the nature, my dear friends, specific heat capacity of water is what? And that is the reason water maintains what temperature. I repeat again, water getting heated up also takes more time. Water losing that heat also takes what? More time. In between, it maintains what? Temperature. And that is the reason coastal area will be maintaining what? Temperature. So as you move away from the coastal area, one land will start behaving purely like that of a. Okay. And one more thing, see, water, do not treat that water will be cold. No. It depends on the season and it depends on the latitude. Lower latitude and summer season, same latitude, water will be colder, land will be warmer. You go to the higher latitude or winter, it is vice versa. Land will be colder and water will be warm. Okay, so it depends on the season. It depends on the latitude. Okay. So I thought of one more question. This 2023 question. Fine. Running short of time. Just winding up. See one thing. We know that, okay, all the topics cannot be done. But before the last 15 minutes, what I'll do, whatever I am not able to complete it, I'll give you as the topics. list of topics where, obviously speaking, before going to the examination, you have to do it. Okay, you have to do it somewhere. In the sense, at least see that, right? Somewhere you ensure that, okay, you have at least read this once. Okay, I'll give you this list of topics. And most of the topics where you'll be finding that certainty of the question is not very, very high. And the size of this chapter is not so great. Okay, right. Now, my dear friends, coming back to this distribution of this temperature, this isothermal bend also, one thing I understand, isotherm, this was the question that was asked in 2024, last year. When exactly this isotherm will be bent, means which direction it will be almost taking a bend. 2023 also the same chapter we had one question. Same chapter. I'll show you that question. 24 we have solved it. Okay, 23. Okay, I'm taking this isotherm of January and isotherm of July. Simple, winter and summer of northern hemisphere. Okay. Now, generally, what I understand, whenever this isotherm is somewhere crossing this from land to water or water to land, always you find a bend. Okay, you find a bend, kind of a bend you find. Okay, what this bend strongly suggests, the same latitude, temperature between land and water is different. That is what this bend is suggesting. Summer also you will be somewhere seeing this bend, winter also you will be seeing this bend. Okay, now I'm asking you, what I'm asking is very simple. Between January and July, which season, take only northern hemisphere, right? Because when I talk about, say, for example, summers, winter means, January winter means, I'm talking about northern hemisphere. Okay. Winter versus summer, only northern hemisphere, forget about southern hemisphere. You have to tell me which season the bend is more. Anomaly. Which season the difference between land temperature and the water temperature will be more. So seeing the image, it is winter. Even NCERT says what? If I'm just looking for this NCERT also says, talk about these isotherms. Okay. I'm just talking about this isotherm. So what exactly they say? And see my difference, I'll tell you. This paragraph, right? This particular paragraph, only one paragraph. This paragraph, it was 2023 question. This paragraph was 2024 question. 2024 question. So somewhere, repeatedly, I'm telling you the importance of climatology and importance of NCR. I'll show you. What exactly this paragraph says? In general, the effect of latitude on the temperature is well pronounced on the map. An isotherm or generally parallel to the latitude, the deviation from this general trend is more pronounced in January than in July. Very, very important, the statement. What exactly the statement they're saying? I'll highlight it, right? The deviation from this general trend is more pronounced in January than in July. Okay. It means somewhere they are saying this deviation is more. Bend is more in where? January. Right. Now I'll show you this question. 2023 question. Okay. This is 2023 question, my friends. Okay. Last to last year. Now you read it. Statement 1. Just to read statement 1. Statement 1. What exactly they say? The temperature contrast between continent and ocean is greater during summer than in winter. Simply you tell me whether the statement is right or wrong. Statement 1. The statement is wrong because I understand the temperature contrast is more during winters than in summers. They are saying it is more in summers. Okay. If the statement 1 is wrong, what is my answer? No need to check statement 2. Directly my answer will be what? option D. Okay, right. Fine, NCERT line by line, it is given. Kindly take NCERT seriously. Okay, going back to this isotherms. Water, I have told you about water. One question we have just taken it. Right. Apart from water, right, ocean currents. Only two types of ocean currents, cold and warm. Okay. So whichever ocean current is coming, okay, whichever region is coming under the influence of cold currents, temperature would be colder. Whichever region is coming under the influence of warm current, temperature would be warmer. And one more thing, climate as a concept is applicable only to the land. Okay. I cannot talk about climate in oceanic region, but oceans can always influence what climate. So see, any ocean current you take, generally exceptions are there, except this temperate region you leave it. Except the temperate region, rest of the region you take it. Right? All that currents which is running along the coastline, you call them as a boundary current. These are the current which will be influencing the temperature. Right? Now, my dear friends, when I just talk about this boundary current, cold boundary current will reduce the temperature. Warm boundary current will increase the temperature. You take any ocean, put yourself in the center of any ocean, you find one similarity. What is similarity? Any ocean you take it, western side of the ocean will be warm. Right? Any ocean. Eastern side of the ocean will be warm. What is west of ocean will become east of land. That you keep it in mind. And ocean current is very simple. Remembering the names, how to remember the names, very simple. Ocean currents is named after the coast. Peruvian current, named after Peru. Brazilian current, named after Brazil. Benguela current, named after the island called as Benguela. West Australian current, western side of Australia. East Australian current, eastern side of Australia. Gulf Stream, Gulf of Mexico. Canary current, Canary Island. California, Californian Peninsula. All right. So any current you take, it is named after the coastline. So don't take too much of tension in remembering the names as such. And finally, what determines the temperature along with the major factor, local factor? What may change from time to time? Cloud. See, already I told you, cloud during the daytime will reduce the temperature. Whereas cloud during the night time will be what? Increasing the temperature. Why? Simple. Cloud does dual activity. Daytime it will be reflecting the insolation, that reduces the temperature. But night time, cloud will not allow the terrestrial radiation to escape. So it will be making the condition warm. And that's the reason whenever you have cloud cover during the night time, you will not have any dew frost or dew or frost formation. Right? Cloud, if at all, if I have cloud cover during the night time, condition will be. Right? That's the reason always we say cloudy days will be colder than cloudless days. Cloudy nights will be warmer than cloudless nights. Okay. Right, my dear friends. It is all about temperature. Right? And we also have a small concept called as temperature inversion. Slightly, let me skip that. Okay, atmospheric pressure. I assume that you largely know about atmospheric pressure. There are 7 permanent pressure systems. Every 30 degree you travel north and south, I'll be having an alternate sequence of pressure system. Only one I have to remember, equatorial region, equatorial. 30 degree north and south, subtropical line. Otherwise also called as horse latitude. 60 degree north and south, I have something called as subpolar low. 90 degree north and south, I'll be having something called as polar high. My dear friends, let me tell you, this pressure belt is very important. Why pressure belt is very important? Only if I know where exactly I have the pressure belts, I'll be knowing the planetary winds. Because wind always moves from high pressure to low pressure. Okay. For example, I have a wind which is flowing from polar high to subpolar. This wind we call them as polar wind. I have a wind which is moving from subpolar high, subtropical high to subpolar low. This wind I call them as what? Westerly. And I have a wind which is moving from subtropical high to equatorial low. This wind we call them as what? Trade winds. Okay. Only if I know where exactly the pressure belts are, I'll be knowing about what? Wind as such. So totally there are 7 pressure belts what we have. 4 in the northern hemisphere, 4 in the southern hemisphere, and 1 being common to. So what is common? Equatorial low is common to what? Okay. Now here, we do call this some of the pressure systems as thermal direct and thermal indirect. somewhere skip it. Okay. Now, knowing the pressure system is very important. As I said, only one you remember. Equatorial region, low pressure. That alone you remember. Every 30 degree you travel. 30 degree. Till 23.5 degree, it is tropical. Slightly beyond the tropic, it is subtropic. Low becomes high. Subtropical high. 60 degrees, slightly beyond the polar region. You call them as what? Subpolar region. High becomes low. Subpolar. 90 degree, polar high. Right? Every 30 degree low pressure will become high pressure, and high pressure will become what? Low pressure. Okay. So kindly note it. Why this pressure system is very important? Because pressure system, this is the one causative factor of what? Wind as such. Wind always moves from high pressure to low pressure. Now, my dear friends, when talk about this pressure system, the pressure belts of the world kindly concentrate. Can say, for example, I also would request you to concentrate on what? Cyclones. Okay. Right. For last half an hour, what I'll do, instead of getting into the details of the topic, as I browse, I'll tell you that this topic is important for the examination, where to concentrate. Okay. This much I'll tell you. If you have any notes or later also you can note down this topic, it will be very important. Later means not after the exam. Okay. Right. Now here, cyclone, I'll take it. Now, wind as a chapter. Wind is very, very important. Very important. Mark it. Very important. Number of questions they have asked for this wind. Right. When I talk about this wind, predominantly I'll be having wind flowing at two places. One at the tropopause level, another at what? Surface level. What is very important for me is at surface level. Okay. Surface level. The surface wind, my dear friends, depending upon the size, we call it as a planetary winds, which will be covering the larger regions of the planet. Near complete planet will be covering. You call them as what? Planetary winds. Covering a larger area, but not to the extent of planet, we call them as what? Regional wind. Either it can be intercontinental or it can be intracontinental. Right? Though there are few winds, the most important wind is what? Monsoon. And very small area winds, we call them as what? Local winds. Local winds is very, very important. Monsoon as a mechanism is what? Very, very important. Repeatedly, they have asked about what? Monsoon. Right. And when I talk about upper air wind, my difference, upper air wind, we have in the name of what? Jet streams. Okay. Between the 7 planetary winds, between the 7 pressure belts, I'll be having the 6 planetary winds, 3 in northern hemisphere and 3 in southern hemisphere. Okay. Approximately, if I just show you, right, what are the planetary winds? Totally, I'll be having 6 planetary winds. Now, there is also, we call it as a regulator of whatever determines the velocity and the direction, we call them as what? Regulator of. Okay, in that way, if you ask me what are the different regulators we have, number one, we call them as what? Pressure gradient force. A force that is created because of the pressure difference that exists between two places. Pressure gradient force. Right? Higher is the pressure gradient force, more will be the velocity. What is very important, they will be determining both direction and velocity. Number two, we'll be talking about Coriolis force. Last year, 2024, this was the question asked. They have asked about Coriolis force. How many questions? 2024, climatology alone, how many questions you see? They have asked Coriolis force. I'll show you. Right? What exactly is the question they have asked? Coriolis force. See? With reference to the Coriolis force, which of the following statements are correct? It increases with increase in wind velocity. Actually speaking, answer is yes. It is maximum at the poles and absent at the equator. Again, it's very simple. One statement you take it, Coriolis effectivity will increase with increasing latitude and increasing velocity of the wind. Both the statement what is given is what correct. But just to tell you, Coriolis force itself is a deflective force. It is caused due to the rotation of this earth. Will be determining only the direction of this wind. Very, very important. And as already suggested, Coriolis force is absent at equator. That's the reason. Coriolis force is one of the causative factor for cyclones. And somebody is asking you why cyclone is absent at equatorial region. Primary factor is Coriolis force is absent. What makes it as a circulation is Coriolis force. Okay. regulator of the wind is very important, right? Frictional drag. Friction is more, velocity will increase. Plains versus mountain, plains wind velocity will be more, mountains wind velocity will be less. Land versus water, land the velocity of the wind will be less, water it will be more. Why? Friction. More is the friction, velocity will be less. Where what? We have to understand. Okay. So kindly go through this regulators of the wind. Okay. See why regulator? I'm telling you, entire climatology is important. Somewhere, when we were concentrating, you see, every chapter we take it 2024 question was there. 2023 question was there. Hardly we went for 20. Only one question, 2018 I went. Otherwise, these 2 years it is dominated. Okay. Wind is very, very important topic. Planetary wind, my dear friends, just know which direction, why it is called as westerly, why it is called as easterly. When I talk about westerly wind, once I take it, any wind you take it, wind is always named from which direction it is coming from. The only wind which is coming from the west, you call them as westerly. All other wind is what? Easterly. Okay, right. So where to where? I repeat again, or I can put it this way: the lower latitudinal wind, trade wind; the mid latitudinal wind, westerly; higher latitudinal wind, polar. From where to where approximately this wind is flowing, that alone you take it, right? Okay, planetary wind, entire wind as a chapter is very, very important. Okay, and we also have local winds, small area winds, sea breeze. Wherever I have a coastal area, I'll be having sea breeze and land breeze. Wherever I have a mountainous region, I'll be having valley breeze and mountain breeze. Only thing is that I have to know which part of the day I'll be having a sea breeze, which part of the day I'll be having a day breeze. Sorry, land breeze. Similarly, which part of the day I'll be having mountain breeze and valley. So all these slides I'll be sharing it. Just go through the slides. Most of the places I have just mentioned. Okay. Then I have just given individual specific names, right? Names, even say, for example, when I talk about India, we have winds like mango showers, tea showers, cherry blossom, blue has caused, say, for example, almost casualties in the northern parts of India nowadays. Okay. So these are some of the specific names of a local. What is the nature of this local wind? Whether this is a cold wind or a warm wind, whether it's a dry wind or a wet wind, I have just classified. Kindly go through. Okay. Some of the descending winds of the world like Chinook, Santa Ana, Zonda, Fohel, cold and dry winds, extremely cold winds like blizzards, purgas, pamporos, right? And other winds also I have the same. Dusty winds, we call them as a dusty winds. All the winds, what I have just showing you is largely from what Sahara does. Sahara does, Harmattan, right? Siraku, Kamsin, Simoon, all these winds as such. Just go through it. Okay. Local winds of India is also equally. And my dear friends, jet stream. Jet stream is there in northern hemisphere as well as what? Southern hemisphere. Okay. So last to last year, they have asked one question. Okay. What is that question they have asked? They asked about jet stream 2020. Okay. Jet stream occur in northern hemisphere only. See, sometimes very sarcastically I used to say, whenever you come across words like only, you mark it wrong. Whenever you come across words like some, you mark it right. Very interestingly, I have both the words coming in. Only some cyclone develop. Okay, whatever it is, again, statement one is wrong. Okay, if statement one is wrong, generally what I understand is wherever statement one is coming, I am removing it. Okay, one is removed, D is means A is removed, D is. Okay, now automatically two is correct. So two is not my decider. What is my decider is what? Three. Right? Do you read it? You don't read it, automatically it is correct. Okay. The temperature inside the eye of a cyclone is nearly 10 degrees less than the surroundings. Okay, you tell me. We have not discussed about cyclone. You tell me whether the statement is right or wrong. We have not discussed about cyclone, but still I am asking you, what about the fate of the statement? The statement is right or wrong? Was this is wrong? Why wrong? See, this 10 degree and all you leave it. 10 degree and all, it is, say, for example, it is just a, it is a psychological fact. Fact all, you leave it. Temperature inside the eye, the center of the cyclone, you call them as what? Eye. Eye is an intensified low pressure. If the pressure system is low, what should be the temperature? Temperature should be high, correct? Because one of the causative factor for creating cyclone itself is what? High temperature. Okay. It is extremely warm. Then only I can have intensified low pressure. But what they are saying, it is less than the surrounding. No, it is much warmer than the surrounding. 10 degree is not a fact to be taken, but whether it is less or that is a fact to be taken. Okay. So answer to this question is what? Only C. My dear friends, I would recommend at least previous year's question you solve before going to the examination. UPSC has a language and UPSC has nuances. That you should not miss it. Okay. Statement 1, why I have removed it is very simple, because jet streams are there in what? Both the hemispheres. Okay. Right. Jet stream is very important. Just go through the jet stream, and jet stream induced precipitation in India, western disturbance. That is also very, very important. Okay. Hydrological cycle. Somewhere I have differentiated between this relative humidity, specific and absolute humidity, not that much needed. But one more, somewhere if I can or you can understand the difference between saturated and unsaturated air mass, this is very important. Okay. Now see, condensation. Condensation is very important. Okay. What is condensation? What is a precondition for condensation taking place? Simple. Water vapor either becoming water droplets or ice crystals. Gas either becoming liquid or solid, you call them as what? Condensation. There, precondition needed for condensation is also very important. Air mass should be saturated, and it should also have hygroscopic nuclei. Generally, we say aerosols are very important. Aerosol determines what? Climatic aspect. In what way? Two ways. One, aerosol will be determining the temperature. How? By scattering insolation. Number two, aerosol plays a very important role in facilitating condensation. Condensation is a prerequisite for precipitation. Right? Hygroscopic. Aerosol will be acting as this hygroscopic nuclei. Okay. So just look for this condensation, precondition, and forms of condensation. Condensation happening in the land during the winters, cloudless nights, dew and frost. When cloud is there, condensation will not take place on the ground. On-ground condensation will not take place. Why? Because for on-ground condensation, any condensation to take place, temperature should be cold. Okay. Whenever I have a cloud during the night time, temperature will be warm. That's the reason normally we say, we had one question also. I think 2019 we had one question, right? They asked why dew drops do not form on a cloudy night. I'll show you the question also if it is possible. Okay, not mentioned here. Oh. Coming back. Even clouds and types of clouds, you just see it. Otherwise, it is not that much needed. Cyclone. Cyclone is very important. Cyclone is very, very important. Precondition needed for cyclones. What is a cyclone? Cyclone, see, cyclone, I have two types of cyclone. Tropical cyclone and temperate cyclones. What we experience, including the one which is coming all the way, right? Shakti. Right? Including Shakti, what I understand, it is a tropical cyclone. Cyclone occurring in the temperate regions, you call them as what? Temperate cyclones. Basic difference between them, what is what you understand. Okay. Then what is very, very important is what? Tropical cyclones. When I talk about tropical cyclones, what are the preconditions? Right? We say high temperature, high amount of moisture, Coriolis force, and pre-existence of temperature. Right? What is the precondition alone? Somewhere Europe, somewhere take it. And the structure of cyclone is very important. Where are the different regions in the world? See, cyclone is not universal. Only 7 regions in the world will witness what? Tropical cyclones. What are the 7 regions? And in that 7 regions, how exactly the cyclone is somewhere referred as, called as, that also I have mentioned. North American region, you call it as hurricanes. Indian Ocean region, you call them as cyclones. South China Sea, you call them as what? Typhoon. And the Australian region, you call them as what? Williams. Right? Tropical cyclones. Structure you concentrate, right? And when it comes to temperate cyclone, the basic information, the different stages, right? That alone you concentrate. Okay. And my dear friends, monsoon is a very important topic. Repeatedly, they have asked plenty of questions in monsoon. Okay. 1, 2, 3, 4 questions. One single topic, almost they have asked 4 questions. Okay. Now see, try to understand monsoon. Seasonal reversal of wind, we call them as what? Monsoon. Okay. Why monsoon? Monsoon we experience primarily because of the shifting nature of this IT season. Shifting nature. Okay. What is northwest monsoon? Sorry, what is southwest monsoon and what is northeast monsoon? In principle, you understand. And what is very important, somewhere, what phenomena may affect this monsoon? Right? Predominantly, we'll be talking about phenomena like El Nino and La Nina of Pacific Ocean. And Indian Ocean dipole, as the name itself suggested, is Indian Ocean. I'll be having both positive phase and negative phase. Okay. See here, El Nino is completely in Pacific Ocean. Temperature anomaly between the two sides of Pacific Ocean. The same temperature anomaly between two sides of Indian Ocean, you call them as what? Indian Ocean dipole. Okay. See here, when examiner is asking you a question, I'm seeing a pattern again. Monsoon, if you ask me what is the definition of a monsoon, I would say the seasonal and regional reversal of wind. When I see this word reversal, there itself I know that they're talking about what? Monsoon. Such a simple question. Okay. Now the slightly complicated question. Indian Ocean dipole is now not in there in news. It is not there in news. So don't worry. But El Nino, last year it was there in news. This year we are talking about La Nina. La Nina is a favorable condition for Indian Ocean. So this year, say for example, somewhere we feel that okay, the monsoon can be as normal as possible because La Nina condition is persisting. So somewhere I would recommend that this year El Nino and La Nina can be on the question paper. Okay. Now see, one similarity you see here, how exactly the questions are being framed. They're talking about with Indian Ocean dipole sometimes mentioned in the news while forecasting Indian monsoon, which of the following statement is correct? IOD phenomena is characterized by the difference in the sea surface temperature. El Nino or La Nina, Indian Ocean dipole, positive or negative phase, whatever it is the case, it is all about difference in sea surface temperature between tropical Western Indian Ocean and tropical Eastern Pacific Ocean. First part of the question is correct. But somewhere I told you, Indian Ocean dipole means between different regions of Indian Ocean, where Pacific Ocean comes. Nothing to do with Pacific Ocean. Statement is wrong. Okay. Second statement. An Indian Ocean dipole phenomena can influence an El Nino impact. Actually, yes. Since we did not get into it, we are not able to do it, but somewhere can influence. And one more thing, whenever examiner is using words like can, may, is increasing the probability of the statement can be what? To be right. But whatever it is the case, I'm not more worried about the statement 2. Statement 1, I am rejecting it because there is nothing to do with what? Pacific Ocean. Okay, similarly, one more year, they have asked another question. Okay, they're asking about La Nina. In La Nina, they say, La Nina is characterized by unusually cold ocean temperature in the equatorial Indian Ocean, whereas El Nino is characterized by unusually warm temperature in equatorial Pacific Ocean. Pacific Ocean is okay, but it has nothing to do with what? Indian Ocean, right? For Indian Ocean dipole, they have included Pacific Ocean. For Pacific Ocean phenomena, they have included Indian Ocean. You're getting it? So in both the ways, statement is wrong. And read the second statement. Extreme words. Read it. El Nino has adverse effect on southwest monsoon of India, but La Nina has no effect. No is absolute word. Extreme word. No is extreme word. Whenever this extreme words comes in, cautiously read the statement again. Okay. All right, my dear friends. Now, monsoon, please do it. And World Climatic Classification. See, World Climatic Classification, Köppen's classification is there. Since last year, one question is asked, somewhere I would recommend 4 climate, you take it very seriously. 13 climates are there according to the classification, but I would recommend this equatorial climate, savanna climate, desert, and Mediterranean. This 4, you kindly take it very seriously. Nothing. NCERT, just see equatorial region, what are the unique characters? And savanna, only one question is asked, okay, if you want to read it, you read it. Tropical, desert, and Mediterranean. I bet this 4 is important. Savanna also, you keep it as 4th one. Equatorial, tropical savanna, tropical desert, Mediterranean type of climate. This 4 alone, kindly concentrate. See why I'm telling you, NCERT, just basic facts in NCERT. I'm just passing it. I'm just telling you how many questions are asked, right? See, 1 question, 2 question, 3 question, 4 questions, 5 question, 6 question, 6 question. Okay. It means once in 2 years, 1 question is there. Right. So kindly go through this climatic classification, right? Whatever it is. NCERT Copen's classification is given, nothing wrong in it. Just go. Right, my dear friends, finally coming to oceanography, just telling you where to concentrate, what to concentrate. I cannot go beyond it. Oceanic features and all, you leave it. Okay. Ocean water property, kindly concentrate on salinity distribution. Kindly take it somewhere. Salinity distribution. What is average ocean water salinity? What are the factors which determines the salinity? How exactly the salinity is distributed both vertically and horizontally. Horizontal distribution is very important. Most saline water region, tropical waters. Least saline water, subtropical water. Sorry, excuse me, subpolar waters. Okay, salinity distribution. Then, when it comes to ocean water movement, ocean current is very, very important. Very, very important. And also look for tides. Okay, so we're looking for tides. Few new terms also you come across. You come across terms like Kallakadal. You come across terms like king tide. These are some of the terms what you come across. Okay. So kindly go through this tide and ocean currents, 2 things. So oceanography, entire oceanography, I would recommend only 3 topics. Last minute, salinity, ocean currents, tides. Okay. Right, my dear friends. With this, I'll also give you the topics of Indian geography where somewhere I feel you should look around. See, Indian geography, physiographic division is okay. Entire India is divided into how many physiographic divisions? That's okay. But in that, say for example, different ranges, if at all, if it is there in news, that much you can take it. Okay. Otherwise, this region is what very, very vast. But here I would recommend when it comes to drainage system, generally examination, I would recommend that 7 rivers are very, very important. 7 rivers. Northern rivers 3, peninsular rivers. Northern rivers, Indus, Ganga, Brahmaputra. Peninsular rivers, Mahanadi, Godavari, Krishna, Kaveri. Here, somewhere my intuition strongly speaks. See, for example, most of the time, questions will be either from Indus or from Ganga or from Brahmaputra. This year, since say for example, right, almost say for example, somewhere I feel that okay, only the May 1st, the questions would have set only the beginning of this, right? Almost the process would have been completed by May 1st. So somewhere, when I just talk about the suspension of this Indus Water Treaty, again, I feel that Indus along with its tributaries becomes very important. So somewhere, if possibly speaking, you try to cover nook and corner of this Indus Valley or Indus River systems, right? Not only Indus, along with its tributaries, right? Even include, say, for example, Chenab, Jhelum, Ravi, Bias, Satluj, all you can. Okay. Even if you want to include Shayok, even if you want to include Galwan, you can include. Okay. Now, how to prepare for a river? Course of the river. Number one, source of the river. Where exactly this river is originating from. Number two is course of the river. What are the different states or the countries through which this river is flowing? Right? Source of the river, course of the river. Very important places located along the banks of this river. Some very important cities, very important tourist places, cultural importance, right? If not, say, for example, national park, biospheric reserves, wildlife sanctuaries, whatever it is. Then what are the different dams, particularly when I talk about Indus Water Treaty that is being suspended, dams are very, very important, right? Very important dams. What are the different dams which is very recently the water has been flushed out? To all, say, for example, flush out the slurry and others. Dams, lakes, reservoirs is very important. Waterfalls located along this river is very important, right? And my dear friends, very important is tributaries and distributaries, right? With one river, what are the tributaries we have? If at all, if you feel that tributary itself is important, I have to repeat the same exercise. I'm telling you, somewhere my intuition feels that this year you'll be concentrating more on what? Indus. Because last year, 2024, they asked about what? Ganga. Very, very basic question. They asked about, say, for example, the order of this tributaries of Ganga. Right? All, say, for example, this UP rivers. All these rivers, they flow in UP, Uttar Pradesh. Right? All, say, for example, they talked about, almost, say, for example, all are left bank tributaries of them. Right? All this Ganga, Gagra, Gomati, Gantak, Kosi, etc. Okay? They asked about Ganga. So somewhere I feel that this year they'll be asking about what? Indus. Okay? Right. Soil medicines. Climate is Indian climate is okay. Soil distribution. Soil distribution is a very small topic, very small topic. Only 8 types of soils are there in India. Entire India, only 8 types of soils are there, right? Only 8 types of soil. In that 8 types of soil, 4 is very important. And one more thing, see, I'm just giving you the questions asked in reverse. This question is about Brahmaputra. This is about the peninsular river, that to Godavari. Again, they ask about what? Brahmaputra. They're asking about Indus. Last year, it was about Ganga. Okay. Now, soils. Predominantly, we have only 8 types of soils. In these 8 types of soils, only NCERT is enough. Don't go beyond it. Only 8 soils is enough, right? Only you talk about, say, for example, 4 soils you kindly read. Alluvial soil, black soil, red soil, and laterite soil. Where is the distribution? What is the uniqueness of this? This alone you know. Okay. Very small topic. Somewhere, examination time, I feel that 20 minutes you can complete it. And see the number of questions that is being asked, right? Simple, very, very small topic. 1 question, 2 questions, 3 questions, 4, 5, 5 questions. Topic is so simple, but repeated questions are 5. Okay. Then, my dear friends, slightly going beyond the physical geography, agriculture in India. And talk about agriculture in India, what I want you to do, again, this particular topic, if possible, what you do, largely you rely on NIOS material. Rely on NIOS material. Because NCERT do not speak sufficient facts about it. 3 things you have to concentrate. Number 1, temperature needed for the crop cultivation. Number 2, precipitation or rainfall needed for the same. Right. Number 3 is soil, conducive soil for the same. Temperature aspect, rainfall, and soil. Right. Not everything I'm telling you. Rice, wheat, millet. When it comes to food grains, I'm giving you only 3. Rice, wheat, millet. When it comes to commercial crops, again, I'm giving you only few. Cotton, jute, and sugarcane. Jute and rice, they are similar. Jute and rice, they are similar. If you're done with rice, you're done with jute. If you're done with jute, you're not done with rice. Same condition. I repeat again, food grains only 3. Rice, wheat, and commercial crops only 3. Cotton, jute, and sugarcane. Plantation crops only 2. Tea and coffee. This much you do. right? Not in detail. What I'm saying is, what is the temperature needed? What is the rainfall amount? What is the soil type? Right? Whether the soil should be well drained or it should be retaining. Okay. Whether it is having a self-flowing capacity or not. Right? NIOS material talks enough about it, and questions are directly picked from NIOS material. Only chapter of agriculture, nothing beyond it. Only, say, for example, 3 plus 3 plus 2. Only the 8 crops you have. Okay. And repeatedly you'll be finding, right? Say, for example, small topic. Again, say, for example, they'll be asking repeated questions, right? 1, 2, 3, 4, 5, 5 questions. Okay. And finally, my dear friends, natural vegetation. Superficial data, right? Particularly if you are doing this natural vegetation in NCERT, where to concentrate? Each and every, say, for example, natural vegetation, what is the dominant species? Okay. By what area it covers and what is the dominant species, right? This much you cover, right? It should be more than enough. For example, I told you, right? For example, tropical deciduous forest, right? In that way, if I'm just talking about moist deciduous, what are the prominent species? Dry deciduous, what will be the prominent species? This much you read it. I think for examination, you can manage. Okay. So, right, my dear friends, now almost some of the topics we have discussed in detail. Some of the topics I have just told you that this is important for the examination. This is what you have to do. Okay. So, any questions from your side, you can ask me. Otherwise, we can conclude this session. And I wish you all the best for the examination. Whatever the knowledge you have, more than enough. It is all about management. You have to overcome your commotions and emotions. Okay. Right. I wish you all the best. God bless. Right. Any questions, kindly let me know. And when it comes to map-based question for international areas, okay, kindly look around, right? Some of the areas, let me give you that one also you can mark it. Mediterranean Sea region, kindly mark it. Central Asia, okay, to some extent, okay. You can mark Central Asia. Along with the Commonwealth independent states, you can mark it. But Mediterranean region, take it for sure that 1 or 2 questions will be there in this Mediterranean region. Okay. All right, my dear friends, thank you. God bless you once again. Wish you all the best for this examination. Come out with the flying colors. God bless.